Subscribe to the channel so you don't miss out on any of these videos. The cosmos is full of mysteries, but some of the most intriguing ones aren't found in the distant reaches of space. They're hidden right here in our own celestial backyard. Before we ever discovered exoplanets orbiting distant stars, astronomers believed there were hidden planets within our solar system itself, lurking just beyond the veil of observation. These lost worlds, Vulcan, Planet X, Nemesis, once held the promise of discovery, only to be dismissed, forgotten, or even ridiculed. But what happened to these missing planets? Were they ever real, or were they merely ghosts born from flawed calculations and hopeful speculation? To understand the rise and fall of these so-called forgotten planets, we must go back to the days when astronomers believed the cosmos was more predictable than it truly is. They looked at the orbits of planets, searching for tiny deviations, anomalies that might hint at the gravitational influence of an unseen world. Sometimes they thought they found one. Other times they were so convinced by theory that they ignored contradictory evidence. And in rare cases, these planets were thought to be real, only to vanish when science caught up with observation. One of the most famous lost planets of our solar system is Vulcan. No, not the home of Spock from Star Trek, but a hypothetical planet once believed to exist inside Mercury's orbit. In the 19th century, astronomers were baffled by Mercury's strange movements. Its orbit didn't behave exactly as Newtonian physics predicted, leading some to suggest that an undiscovered planet must be perturbing Mercury's path. French mathematician Urbain Le Verrier, who had already successfully predicted the existence of Neptune using a similar method, proposed that a small planet, or perhaps even a series of asteroids, was hiding close to the Sun. He named it Vulcan. For years, astronomers searched for Vulcan, and some even claimed to have seen it. Reports surfaced of small dark spots transiting the Sun, believed to be this mysterious world. Some were mere sunspots. Others were optical illusions. But the idea persisted. Even Le Verrier, despite mounting skepticism, remained steadfast in his belief that Vulcan was real. However, as observational tools improved, Vulcan remained stubbornly absent. No telescope ever definitively captured it. Eventually, Albert Einstein's theory of general relativity explained Mercury's orbital irregularities without needing a hidden planet. Gravity itself, as Einstein described it, warped spacetime around massive objects like the Sun, causing Mercury's orbit to shift in a way that Newtonian physics alone couldn't predict. Vulcan was no longer necessary. It was erased not by observation, but by a deeper understanding of physics. But Vulcan was just the beginning. As our understanding of the solar system grew, new anomalies appeared, and with them, new theories of hidden planets. Enter Planet X. Planet X has been one of the most tantalizing and persistent ideas in astronomy. The term, Planet X, was first used in the 19th century to describe an unknown planet that might be affecting the orbits of Uranus and Neptune. When Neptune was discovered in 1846, it was initially thought to be the final missing piece of the planetary puzzle. However, astronomers soon noticed that Neptune itself exhibited strange deviations in its orbit, deviations that seemed to hint at another unseen world beyond it. The search for Planet X gained momentum in the early 20th century, led by astronomers like Percival Lowell. Lowell, a wealthy and ambitious scientist, dedicated much of his career to finding this elusive planet. He even built an observatory specifically for this purpose, scanning the skies for any sign of a distant world. In 1930, his efforts bore fruit, sort of. Clyde Tombaugh, working at Lowell Observatory, discovered Pluto. Many initially thought Pluto was Planet X. But there was a problem. Pluto was too small. Its mass wasn't nearly enough to influence Neptune's orbit the way Lowell had predicted. For decades, Pluto remained the supposed Planet X, even though its gravitational effects didn't add up. Then, in 2006, Pluto was famously reclassified as a dwarf planet, officially ending its reign as the 9th planet. But the idea of Planet X didn't disappear. Instead, astronomers kept searching, believing that something massive was still out there. More recently, studies of extreme trans-Neptunian objects, icy bodies beyond Neptune, have suggested that they follow strangely clustered orbits. Some scientists believe this clustering could be caused by a massive, unseen planet lurking in the outer solar system. This hypothetical world, sometimes called Planet 9, has not yet been directly observed, but the search continues. Even more ominous than Planet X is the idea of Nemesis, a hypothetical dark companion to the Sun that might have been responsible for mass extinctions on Earth. The Nemesis hypothesis emerged in the 1980s when scientists noticed a strange pattern in Earth's fossil record. Mass extinctions seem to occur in a somewhat regular cycle, roughly every 26 million years. Could something out in space be periodically disturbing the solar system, sending comets hurtling toward Earth? Some astronomers propose that our Sun might have an undetected companion star, a dim red or brown dwarf orbiting far beyond Pluto. This hypothetical star, dubbed Nemesis, would occasionally pass through a region of space filled with comets, the Oort cloud, gravitationally nudging them toward the inner solar system, increasing the likelihood of catastrophic impacts. If true, this would mean that Earth's history of destruction, from the dinosaurs' demise to other mass extinctions, might be linked to an invisible celestial assassin. However, Nemesis has never been found. Despite decades of sky surveys, no evidence of such a companion has appeared. Advances in infrared astronomy should have been able to detect a dim star orbiting the Sun at such a distance, yet nothing has been observed. Some researchers believe the periodicity of mass extinctions is an illusion, a coincidence rather than a cosmic cycle. Others have suggested that a massive but unseen planet, rather than a star, could be responsible for the disturbances. While the Nemesis hypothesis has largely fallen out of favor, it remains a chilling reminder of how much we still don't know about our own cosmic neighborhood. The forgotten planets of the solar system are more than just failed predictions. They are a testament to the evolving nature of science. Each of these hypothetical worlds, Vulcan, Planet X, Nemesis, represents a stepping stone in our understanding of the universe. At the time of their proposals, they were plausible solutions to real mysteries. That they were later disproven does not mean they were foolish ideas. Rather, they were necessary steps on the path to greater knowledge. And yet, the story isn't over. The search for Planet 9 continues. The outer reaches of the solar system remain unexplored, and strange orbital anomalies still hint at unseen gravitational forces at work. Even the Nemesis idea, though largely abandoned, has morphed into new hypotheses about rogue planets or distant objects influencing the Oort cloud. The ghosts of these forgotten planets still linger, whispering from the edges of scientific inquiry, urging us to keep searching, to keep questioning, and to never assume we know everything about our own solar system. Perhaps, one day, a telescope will catch a glimpse of something unexpected. Perhaps a gravitational anomaly will finally reveal a hidden world, long theorized but never seen. If history has taught us anything, it's that space is far stranger than we can imagine. And maybe, just maybe, some of these forgotten planets were never truly lost at all. The notion of forgotten planets isn't just a relic of the past, it's an ongoing enigma. As telescopes become more advanced and computational models improve, we continue to stumble upon hints of unseen celestial bodies influencing our solar system. Even with the dismissal of Vulcan, the demotion of Pluto, and the fading credibility of Nemesis, the idea that something is still lurking beyond our current reach remains a tantalizing mystery. Could it be that one of these forgotten planets wasn't just a mathematical mistake, but a real world we simply haven't found yet? Or are we doomed to keep chasing shadows in the vastness of space? Planet 9, the modern iteration of Planet X, is perhaps the strongest candidate for a real, undiscovered planet. Unlike earlier failed hypotheses, Planet 9 is based on solid observational data, specifically, the strange clustering of certain trans-Neptunian objects, TNOs. These distant, icy bodies don't seem to be moving randomly. Instead, their elongated orbits are aligned in a way that suggests they are being influenced by an unseen gravitational force. Could this force be a planet lurking far beyond Neptune? If it exists, Planet 9 is thought to be a super-Earth, a world 5 to 10 times the mass of our planet, orbiting the Sun at a staggering distance, perhaps 500 times farther than Earth's own orbit. Its vast separation from the Sun would make it incredibly dim, nearly impossible to detect with current telescopes unless we knew exactly where to look. Some astronomers have suggested that upcoming infrared sky surveys might finally provide evidence of its existence. Until then, Planet 9 remains a theoretical ghost, much like its predecessors. But while Planet 9 is the best supported hypothesis for an undiscovered planet, it's not the only one. Some scientists speculate that our solar system could still be harboring more secrets in its outer reaches. The Oort cloud, a distant shell of icy objects that marks the very edge of the Sun's gravitational influence, is largely unexplored. Could there be an Earth-sized planet out there, hidden among the frozen debris? Some models suggest it's possible, but without direct observations, it remains speculation. Another idea is that a rogue planet, a world ejected from its original solar system, could have been captured by our Sun's gravity in the distant past. If such a planet exists, it could be wandering in a highly elliptical orbit, making it even harder to find. Unlike the neatly arranged planets we know, a rogue planet wouldn't necessarily follow predictable patterns, further complicating the search. Then there's the lingering mystery of Nemesis. While the idea of a dark star companion to the Sun has lost support, the concept of periodic disturbances in the Oort cloud remains an open question. Some astronomers wonder if a distant, undiscovered planet, rather than a star, could still be causing comet showers that occasionally bombard the inner solar system. If so, this planet might be even farther than Planet 9, perhaps lying at the very edge of the Sun's gravitational hold. One of the biggest challenges in proving or disproving these hypotheses is the sheer scale of the search. The outer solar system is vast, and even a planet the size of Neptune could remain undetected if it were far enough away. Our best telescopes, like those of the Vera C. Rubin Observatory, are just now reaching the level of sensitivity needed to scan the sky for such objects. Until we have more data, these forgotten planets remain just that, forgotten, but not necessarily gone. Yet, history has shown that dismissed ideas can sometimes make a comeback. Neptune itself was once a hypothetical planet, predicted before it was seen. The same was true for many moons of Jupiter and Saturn, which were long suspected before they were directly imaged. Could it be that one of the so-called non-existent planets will one day be found? It's possible, and if so, it would be one of the greatest discoveries in modern astronomy. If Planet 9, or some other hidden world, is ever confirmed, it would fundamentally change our understanding of the solar system. It would mean that our current model, which has remained largely unchallenged since Pluto's reclassification, is still incomplete. It would also raise new questions. How did this planet form? Why is it so far from the Sun? And could there be even more planets beyond it? But even if these worlds remain elusive, their stories serve as a reminder of how dynamic science truly is. What we consider fact today may be disproven tomorrow. The search for these forgotten planets has already led to unexpected discoveries, new types of asteroids, strange dwarf planets, and insights into the chaotic history of our solar system. Even when planets themselves turn out to be illusions, the pursuit of them has advanced our understanding of space. So, what does the future hold for the search for missing planets? With upcoming space missions, new telescopes, and improvements in AI-driven astronomical surveys, we are entering an era where the hidden corners of our solar system may finally be revealed. Whether we confirm the existence of Planet 9, stumble upon a rogue planet, or find evidence of an ancient collision that reshaped the solar system, the answers are out there, waiting to be uncovered. One thing is certain, our solar system still holds secrets. The planets we know today may not be the only ones that have ever existed, and the planets we've dismissed may yet return to the conversation. Whether real or imagined, the forgotten planets continue to haunt the edges of scientific discovery, whispering of worlds that might have been, or might still be. The story of the forgotten planets is not just about planets that were once believed to exist but later dismissed. It is also about the limitations of human observation and the ever-evolving nature of scientific discovery. Every time we think we have a complete picture of the solar system, new anomalies emerge, forcing us to reconsider what we know. What if the planets we once dismissed weren't mistakes, but premature conclusions? What if the forces we attributed to non-existent worlds were real, just misunderstood. Consider the peculiar case of Vulcan. While it was eventually disproven as a planet, its story highlights an important truth. Sometimes, the mysteries of the cosmos are not about objects we can see but about forces we don't fully understand. The same principle applies to the ongoing search for Planet 9 and other hypothetical planets. If something is influencing the outer solar system, does it have to be a single planet? Or could the answer lie in an entirely new gravitational phenomenon we haven't yet discovered? Planet 9's proposed orbit is so distant that it would take thousands of years to complete a single revolution around the Sun. If it exists, it may have spent most of human history in a part of its orbit where it is virtually invisible from Earth. Unlike the search for Neptune, which relied on relatively short observational records, detecting Planet 9 requires analyzing centuries' worth of celestial motions. The difficulty in finding such a world reminds us that the solar system is far from a neatly arranged set of planets. It is a dynamic, ever-changing environment where new discoveries await in the most unexpected places. And what if Planet 9 isn't alone? Some researchers speculate that there could be multiple undiscovered objects in the outer solar system. Recent simulations suggest that more than one planet might be needed to explain the peculiar orbital clustering of distant trans-Neptunian objects. If true, our current understanding of the solar system structure would need to be rewritten. The idea that we live in a system with only 8 planets might be an illusion, one that will eventually be shattered by new observational data. But there's another possibility. What if some of these hypothetical planets did exist at some point in the past but were lost to time? The early solar system was a chaotic place, with planets forming, migrating, and even being ejected. Some simulations suggest that a 5th giant planet may have once existed between Saturn and Uranus, only to be flung into interstellar space during the solar system's infancy. If so, it would mean that our Sun once had an additional world that now drifts alone in the vastness of space, a true ghost planet that no longer belongs to any solar system. This brings us back to the idea of rogue planets, worlds that have been ejected from their home systems and now wander through the galaxy, untethered to any star. Could our solar system have captured one of these planets at some point in its history? If so, it might explain some of the strange gravitational anomalies observed in the outer solar system. A captured rogue planet wouldn't necessarily follow the same orbital rules as the traditional planets, making it even harder to detect. The mysteries don't end there. Some astronomers have suggested that there could be small, undetected planets lurking within the asteroid belt or the Kuiper belt. These objects wouldn't be large enough to dramatically affect planetary orbits, but they could explain certain irregularities in the distribution of asteroids and other small bodies. Could it be that the solar system still hides additional planets within its known regions, simply too faint or too small for current telescopes to detect? Another intriguing idea is that our solar system may have once had a binary companion, a second sun that was lost in the distant past. Some models suggest that our Sun could have formed in a binary system, with its twin either being ejected or merging with the primary star. If true, this could help explain some of the unusual distributions of objects in the outer solar system. Could remnants of this lost star still be affecting our solar neighborhood in ways we don't yet understand? The idea of a forgotten solar system extends beyond just planets. Moons, too, may have been lost over time. Some of Jupiter and Saturn's many moons are thought to be captured objects, possibly former asteroids or even dwarf planets that were pulled in by their massive gravitational fields. But what about the moons that weren't captured? If large moons once orbited planets like Earth or Mars, could they have been destroyed in cataclysmic impacts or thrown into space by gravitational interactions? Even within the inner solar system, mysteries remain. The unusual rotation of Venus, the chaotic tilt of Uranus, and the strange density variations of Mercury all hint at past planetary interactions that we still don't fully understand. Did Venus once have a moon that was lost in a violent collision? Was Uranus struck by a massive object that caused its extreme axial tilt? Did Mercury once have a twin that was absorbed by the Sun? These are the kinds of questions that continue to puzzle scientists. Ultimately, the search for forgotten planets is more than just a hunt for missing worlds. It is a search for the history of our solar system itself. Every planet, every moon, and every asteroid tells a story of formation, migration, and destruction. Some of those stories have been preserved, while others have been lost to time. But with each new discovery, we recover a piece of that history, slowly reconstructing the puzzle of our cosmic origins. As technology advances, we may soon find definitive answers to some of these lingering mysteries. The upcoming James Webb Space Telescope, the Vera-C, Rubin Observatory, and future space missions may finally provide the evidence needed to confirm or disprove the existence of Planet 9 and other hypothetical worlds. But even if they don't, the search itself is valuable. Every time we investigate these forgotten planets, we learn more about the forces shaping our solar system. Perhaps the most profound lesson of all is that the universe is not static. Planets come and go, stars are born and die, and even the solar system we know today is just a temporary arrangement in the vast, unfolding history of the cosmos. The forgotten planets remind us that what we consider reality is always subject to change. They are whispers from the past, clues to the future, and a reminder that there is still so much we have yet to understand. And so, the search continues. Scientists will keep scanning the skies, refining their models, and questioning their assumptions. Maybe one day, a new planet will emerge from the darkness, proving that not all forgotten worlds are truly lost. Until then, the mystery endures, waiting for the next great discovery to rewrite everything we thought we knew about our place in the universe. The search for forgotten planets is not just a scientific endeavor, it is a testament to humanity's relentless curiosity and our willingness to challenge our own assumptions. Every time a new theory emerges about an unseen world lurking at the edges of the solar system, it reminds us that our understanding of space is still incomplete. Even as telescopes scan the sky for exoplanets orbiting distant stars, some of the greatest mysteries may still lie within our own cosmic backyard. What if we have overlooked something fundamental? What if a forgotten planet, long dismissed as a mathematical illusion, is waiting to be rediscovered? The history of planetary discovery suggests that the greatest breakthroughs often come when we least expect them. When Uranus was discovered in 1781, it was a complete surprise. No one had predicted an additional planet beyond Saturn. The search for Neptune, guided by mathematical predictions, proved that unseen worlds could be found through careful calculations. Yet, when astronomers tried the same approach to find Planet X, they instead stumbled upon Pluto, a world far smaller than expected. This pattern raises an important question: what if the forgotten planets were simply the wrong predictions at the right time? Could the forces that led to these theories have been real, just misunderstood? Planet 9, for example, is an idea born from the gravitational anomalies observed in the orbits of trans-Neptunian objects. But what if the explanation isn't a single planet, but rather a collection of smaller bodies, or even a fundamentally new kind of gravitational influence we have yet to understand? This brings us to one of the most intriguing possibilities: the idea that our solar system structure is not as stable as we assume. Traditionally, we think of planets as permanent fixtures, following predictable orbits for billions of years. But what if some of the forgotten planets were once real, only to be ejected, destroyed, or merged with other celestial bodies over time? The early solar system was a chaotic place, filled with collisions, migrations, and gravitational battles between planets. Some models suggest that a large planet once formed beyond Neptune, only to be thrown out by Jupiter's immense gravity. If such a planet exists, it is now a rogue world, drifting alone in interstellar space, severed from its birthplace. Could one of the planets we once searched for, Planet X, Nemesis, or even a different, unnamed world, have been a victim of this early instability? Similarly, there is the possibility that planets formed in regions of the solar system where they could not survive for long. Mercury, for instance, is an anomaly, small, dense, and lacking a significant atmosphere. Some theories suggest that Mercury was once a much larger planet, but that a catastrophic impact stripped away its outer layers, leaving only its metallic core behind. If this is true, then an entire planetary body has been lost to time, reduced to nothing but a shadow in the form of the planet we see today. Venus, too, presents an unresolved mystery. Unlike every other major planet, it rotates in the opposite direction, a peculiarity that suggests a violent past. Some astronomers believe Venus may have once had a moon, or even a twin planet, that was eventually destroyed or absorbed. If so, then another world may have existed within the solar system, only to be erased by cosmic forces. And what about Mars? Once a world of rivers and lakes, it is now a barren desert. Some scientists speculate that Mars may have once had a larger, more massive companion, a planet that influenced its climate before being lost in a cataclysmic event. Could a missing planet explain why Mars lost its atmosphere? Could the gravitational interactions of an ancient, forgotten world have altered the fate of the red planet? Beyond the inner solar system, the mysteries only grow deeper. The Kuiper Belt, a region of icy objects beyond Neptune, is home to numerous dwarf planets, but it may also contain larger, undiscovered bodies. Some simulations suggest that a Mars-sized planet could exist in this region, hidden among the icy debris. If true, this would mean that the solar system has an additional planet that has simply evaded detection due to its distance and faintness. Even farther out lies the Oort cloud, a vast, spherical shell of icy objects that marks the boundary of the Sun's gravitational influence. This region is so distant that we have barely begun to study it. Could a massive planet, or even a failed star, be lurking in the darkness? Some theories propose that a gas giant may exist in this region, too far to have been detected but capable of influencing the orbits of comets and other small bodies. If such a planet exists, it could be the key to solving one of the longest-standing mysteries in astronomy, the periodic mass extinctions on Earth. Some scientists have suggested that a distant, unseen planet could be responsible for disturbing the Oort cloud every few million years, sending comets hurtling toward the inner solar system. Could this hypothetical world be Nemesis after all? If so, it would mean that one of the most controversial forgotten planets still holds relevance today. The search for these lost worlds continues, driven by new technologies and innovative approaches. Upcoming telescopes, such as the Vera C. Rubin Observatory, are expected to scan the sky with unprecedented detail, potentially revealing faint, slow-moving objects that could be new planets. Infrared surveys may also help detect planets that are too cold to be seen in visible light. But what if the answer isn't a single planet? What if the true nature of these anomalies lies in something we haven't even imagined yet? The history of astronomy is filled with moments when new discoveries overturned everything we thought we knew. Perhaps the real lesson of the forgotten planets is that nothing in space is ever truly lost, only waiting to be rediscovered. As we push the boundaries of what we know, one thing is certain: the solar system still holds secrets. The planets we have dismissed may yet return to the conversation, and the worlds we have never even imagined may one day be found. Whether it is Planet 9, a lost twin of Earth, or a hidden giant in the Oort cloud, the next great planetary discovery is waiting. The question is not if we will find it, but when. The search for forgotten planets raises profound questions about the nature of our solar system. Have we truly mapped out all the major celestial bodies, or are there still hidden worlds waiting to be discovered? The history of astronomy suggests that the answer is far from settled. Many of the planets we take for granted today, Uranus, Neptune, and even Pluto, were once unknown. They were theorized, searched for, and eventually found. Could the same be true for the so-called missing planets that were once predicted but never officially confirmed? One of the most compelling reasons to believe in the existence of lost or hidden planets is the idea that our solar system may have undergone significant rearrangements in the past. The concept of planetary migration suggests that the giant planets, Jupiter, Saturn, Uranus, and Neptune, did not always occupy their current positions. Instead, they likely moved over time, interacting with smaller bodies, ejecting some into deep space, and capturing others into new orbits. If this process occurred, then it is entirely possible that an additional planet once existed in the early solar system, only to be flung into interstellar space or consumed by one of the larger planets. Some scientists believe that a fifth gas giant may have once orbited the Sun alongside Jupiter and Saturn. According to this theory, the early solar system was a chaotic place, filled with planetary collisions and gravitational disruptions. If this hypothetical gas giant existed, it may have been thrown out of the solar system by Jupiter's immense gravitational influence. Today, it could be wandering the galaxy as a rogue planet, completely detached from any star. If true, this would mean that our solar system was once home to an additional world, one that was lost to the vastness of space. Another theory suggests that a massive, icy planet may still exist beyond Neptune. The Kuiper Belt, which contains thousands of small icy bodies, could be home to a hidden planet that has so far escaped detection. Some computer simulations suggest that an object roughly the size of Mars or even Earth could be lurking in the far reaches of the solar system, influencing the orbits of distant objects. If this planet exists, it would dramatically reshape our understanding of the solar system's structure. The case of Planet 9 is particularly intriguing. Unlike earlier searches for hypothetical planets, which were often based on incorrect calculations, the idea of Planet 9 is supported by solid observational evidence. Certain Kuiper Belt objects display highly unusual orbits that suggest they are being influenced by a massive, unseen body. Scientists estimate that if Planet 9 exists, it is likely to be several times the mass of Earth and orbit the Sun at an extreme distance, possibly taking thousands of years to complete a single revolution. Finding such a planet is incredibly difficult. At such a vast distance, it would reflect very little sunlight, making it nearly invisible to traditional telescopes. However, new infrared surveys and advanced sky scanning techniques may eventually pinpoint its location. If Planet 9 is confirmed, it would be one of the most significant astronomical discoveries of the century, proving that our solar system is still full of surprises. The search for forgotten planets does not stop at the edge of the solar system. Some scientists have even speculated that our Sun could have once had a companion star, a twin that was either ejected from the system or still exists at an extreme distance. This idea is closely tied to the Nemesis hypothesis, which suggests that a distant, unseen star could periodically disturb the Oort cloud, sending comets hurtling toward the inner solar system. If Nemesis exists, it could explain certain patterns in Earth's history, including periodic mass extinctions. Some researchers believe that a red or brown dwarf star may have once orbited the Sun at a great distance, influencing the trajectories of comets and asteroids. However, extensive sky surveys have yet to find any definitive evidence of such a star, leaving the Nemesis theory in the realm of speculation. Despite the lack of direct proof, the idea of a missing companion star is not entirely far-fetched. Many stars form in binary systems, meaning they have at least one gravitationally bound partner. If the Sun once had a twin, it may have been lost in the early days of the solar system's formation. Alternatively, if Nemesis still exists, it could be so faint and distant that it has remained undetected. The concept of forgotten planets also forces us to reconsider the definition of what constitutes a planet. Pluto was once considered the 9th planet of the solar system, but its status was downgraded to that of a dwarf planet in 2006. Since then, astronomers have discovered several other dwarf planets, such as Eris, Haumea, and Makemake, suggesting that the outer solar system is far more complex than previously thought. Some scientists argue that instead of focusing solely on large planets, we should expand our understanding to include smaller, yet significant, celestial bodies. If we take this broader perspective, then the solar system may already contain multiple, forgotten, planets, worlds that were overlooked simply because they did not fit the traditional definition of a planet. The search for these objects continues, and each new discovery adds another piece to the puzzle of our cosmic neighborhood. The question of forgotten planets is not just about individual celestial bodies, it is about the larger mystery of how the solar system evolved. Did hidden worlds shape the planets we see today? Are there still undiscovered planets lurking in the darkness? These are questions that drive astronomers to keep searching, pushing the limits of technology and observation. As new telescopes come online and space probes venture farther than ever before, we may finally uncover the answers. The forgotten planets of the past may soon become the rediscovered planets of the future, rewriting our understanding of the solar system and proving that even in the modern age, the universe still holds secrets waiting to be revealed. The idea that our solar system may contain undiscovered planets or even lost celestial bodies is not just an abstract theory. It is a real possibility supported by scientific evidence and historical precedent. Time and again, astronomers have identified anomalies in planetary motion, only to realize that they were signs of hidden worlds waiting to be discovered. This has happened with Uranus, Neptune, and even Pluto. The difference today is that the search has become more refined, relying not only on mathematical predictions but also on high-powered telescopes, infrared surveys, and deep space probes. One of the strongest pieces of evidence for an undiscovered planet is the unusual clustering of trans-Neptunian objects, TNOs. These icy bodies, which orbit far beyond Neptune, appear to be gravitationally influenced by something much larger. Their orbits are elongated and tilted in a way that suggests the presence of a massive, unseen planet lurking in the outer reaches of the solar system. The fact that these objects share similar orbital characteristics is unlikely to be a coincidence. Instead, many scientists believe that a large, distant planet, perhaps 5 to 10 times the mass of Earth, is responsible for these gravitational disturbances. This hypothetical world, commonly referred to as Planet 9, is thought to orbit the Sun at a distance 400 to 800 times greater than Earth's distance from the Sun. At such an extreme distance, it would be incredibly difficult to detect. It would receive very little sunlight, making it almost invisible to traditional telescopes. The only way to find it is to conduct deep sky surveys using infrared technology, which can detect faint heat signatures rather than reflected sunlight. Several research teams are currently conducting these surveys, and there is a real possibility that Planet 9 could be confirmed within the next few years. But what if there is more than just one undiscovered planet? Some theories suggest that the early solar system may have contained additional planets that were later ejected due to gravitational interactions with the gas giants. Computer simulations indicate that during the solar system's formation, multiple planets could have formed beyond Neptune, only to be thrown into interstellar space by the immense gravitational influence of Jupiter and Saturn. If these planets still exist, they are now rogue planets, worlds without a star, drifting alone through the cold darkness of space. If even one of these lost planets were found, it would revolutionize our understanding of planetary formation. It would suggest that the process of planetary migration is far more common than previously believed and that the early solar system was much more dynamic and chaotic than we imagined. It would also raise new questions. Could these rogue planets have retained atmospheres? Could they have moons? Could they have once supported life before being cast out into the void? The idea of rogue planets is not as far-fetched as it might seem. Astronomers have already discovered many rogue planets in interstellar space, planets that do not orbit any star. Some of these planets are enormous, reaching the size of Jupiter or larger, while others are much smaller, similar in size to Earth. If planets can be ejected from other star systems, it stands to reason that the same could have happened within our own solar system. Perhaps one of the forgotten planets of the past is still out there, drifting silently through space, waiting to be found. Beyond Planet 9 and the possibility of ejected planets, there are also questions about whether additional planets could exist within the Oort cloud, the distant shell of icy objects that surrounds the solar system. The Oort cloud is so far away that we have never directly observed it. We only know of its existence because of the long-period comets that occasionally enter the inner solar system, originating from its depths. If a large planet, or even a brown dwarf exists in this region, it could be influencing the trajectories of these comets. Some astronomers have speculated that the Oort cloud could contain a hidden planet, possibly a gas giant, or even a super-Earth. If such a planet exists, it would be orbiting the Sun at an unimaginable distance, perhaps tens of thousands of times farther than Earth. At that range, it would be almost impossible to detect with current technology, but future telescopes might finally reveal its presence. The possibility of a massive object in the Oort cloud ties into the Nemesis hypothesis, which suggests that the Sun may have once had a companion star. If Nemesis exists, it could explain why Earth has experienced periodic mass extinctions throughout its history. Some scientists believe that a distant, unseen object could occasionally disturb the Oort cloud, sending a barrage of comets toward the inner solar system. While the Nemesis theory remains controversial, the idea of an undiscovered massive body influencing the solar system is still being explored. What makes the search for forgotten planets so compelling is that it forces us to rethink everything we thought we knew about our cosmic neighborhood. The solar system is not a static place, it is a dynamic, evolving system where planets form, migrate, and sometimes even disappear. Our current model of the solar system is based on what we can see, but what about the things we cannot see? The presence of dark matter, gravitational anomalies, and unexplained orbital patterns all suggest that there may be more to discover. With each new technological advancement, we are getting closer to solving these mysteries. The Vera C. Rubin Observatory, set to begin operations soon, will conduct deep sky surveys that could detect faint, slow-moving objects at the edge of the solar system. Space probes like the upcoming Interstellar probe mission may also provide new insights by traveling beyond the known boundaries of the solar system and collecting data on distant celestial bodies. Ultimately, the search for forgotten planets is not just about filling in the gaps in our knowledge, it is about understanding our place in the universe. If we discover new planets, it will mean that the solar system is even more complex and diverse than we imagined. If we find evidence of a lost planet that was ejected long ago, it will change our understanding of planetary formation and migration. And if we uncover a truly massive object in the Oort cloud, it could redefine our definition of what constitutes the solar system itself. As we continue to explore, one thing remains certain: the story of the solar system is far from complete. The forgotten planets of the past may still be waiting to be found, and with each new discovery, we take one step closer to revealing the true nature of our cosmic home. The search for forgotten planets is not just about identifying individual celestial bodies. It is about reconstructing the history of the solar system itself. Every discovery brings new insights into how our cosmic neighborhood formed, evolved, and possibly lost or gained planets over billions of years. What we consider a complete picture today may turn out to be only a fragment of the true story. One of the most intriguing aspects of this search is the possibility that the solar system once contained additional terrestrial planets, similar to Earth, Mars, Venus, and Mercury. Some models suggest that during the early formation of the solar system, there could have been more rocky planets in the inner regions, but intense gravitational interactions with Jupiter or catastrophic collisions may have led to their destruction. These lost planets, if they existed, could have played a crucial role in shaping the current layout of the solar system. A strong piece of evidence for this possibility comes from the asteroid belt. The belt, located between Mars and Jupiter, is often thought to be the remnants of a planet that never formed due to Jupiter's strong gravitational influence. However, some theories suggest that it could be the debris of a planet that once existed but was destroyed in a massive collision. If true, this would mean that the asteroid belt is not just a collection of leftover material, but the remains of a forgotten world. The same idea applies to Mars, which shows signs of a violent past. Many scientists believe that Mars may have once had a massive moon or even another planetary companion that was either absorbed, ejected, or destroyed. The presence of massive impact craters, the thinness of its atmosphere, and its lost magnetic field all suggest that Mars suffered catastrophic events in its history. Could these events have been triggered by the gravitational disturbances of a missing planet? Beyond the asteroid belt, the Kuiper belt and Oort cloud hold even more mysteries. The Kuiper belt, a vast region of icy objects beyond Neptune, is home to Pluto, Eris, Haumea, and many other dwarf planets. However, its structure is not as uniform as scientists once thought. Some objects in the Kuiper belt have highly unusual orbits, suggesting that an undiscovered planet might be exerting its influence from afar. This brings us back to the question of Planet 9. If it exists, its gravitational pull could explain why certain Kuiper belt objects follow unexpected paths. Some researchers even believe that there could be more than one hidden planet in this region, each contributing to the complex orbital dynamics observed at the solar system's edge. If these planets are eventually discovered, they would not only add to the official count of planets in our solar system but also challenge our understanding of planetary formation. Even further out, the Oort cloud remains one of the most mysterious, and least understood parts of our solar system. The objects in this distant shell are thought to be the source of long-period comets, but their exact distribution and composition remain unknown. Some researchers speculate that a large planet, or even a failed star, a brown dwarf, could be lurking in the Oort cloud, occasionally sending comets into the inner solar system. If such an object exists, it could help explain why Earth has experienced periodic comet impacts throughout its history. The idea of a failed star or a giant undiscovered planet in the Oort cloud also raises questions about the nature of our solar system's boundaries. Traditionally, we think of the solar system as ending with Neptune and the Kuiper belt, but if a massive object exists far beyond that, it would redefine what we consider to be the outer edge of our cosmic neighborhood. This search also extends beyond just physical planets. The concept of ghost planets has been discussed in scientific circles, planets that may have once existed but left behind gravitational imprints or debris fields. If a massive planet was ejected from the solar system, its presence could still be felt in the way remaining objects move. Some scientists are searching for these invisible fingerprints, hoping to detect evidence of a lost world. There is also the question of whether any of these forgotten planets could have once supported life. If a large Earth-like planet existed in the habitable zone before being ejected into space, could it have harbored life? If so, what happened to that life when the planet was thrown into the cold void of interstellar space? Could extremophiles, organisms capable of surviving in extreme environments, have adapted to such a drastic change? These questions push the boundaries of what we know about life and planetary habitability. The discovery of exoplanets has shown that planets exist in a wide variety of conditions, from scorching lava worlds to frozen ice giants. If life can exist in extreme environments on Earth, it is not impossible to imagine that a lost planet might have carried microbial life into interstellar space, possibly even seeding life elsewhere in the galaxy. The forgotten planets of our solar system may hold secrets not only about planetary formation but also about the potential for life beyond Earth. Their discovery, or the confirmation of their past existence, could provide clues about how common planets are in the universe, how solar systems evolve, and whether the conditions for life are more widespread than we think. As technology advances, our ability to detect faint, distant objects improves. The next generation of telescopes, such as the James Webb Space Telescope and upcoming infrared observatories, will allow astronomers to peer deeper into space than ever before. These tools may finally reveal the hidden planets that have eluded discovery for so long. In the coming years, new space missions may even visit the outer regions of the solar system, bringing back data that could confirm or disprove some of these long-standing theories. The search for forgotten planets is far from over. It is just beginning. What lies beyond Neptune? What secrets are hidden in the depths of the Oort cloud? Could a lost planet be drifting silently through interstellar space, once a member of our solar system but now a wanderer in the cosmos? These are questions that drive astronomers to keep looking, keep searching, and keep pushing the boundaries of human knowledge. The universe is vast, and even within our own solar system, mysteries remain. Perhaps the next great planetary discovery is just around the corner, waiting for the right moment to reveal itself to us. The search for forgotten planets is not just an exercise in curiosity. It is a fundamental quest to understand the forces that shape the solar system and, by extension, the universe itself. If our solar system has experienced planetary migrations, lost worlds, or even interstellar visitors, these events could provide valuable insights into the broader process of planetary evolution. One of the most compelling ideas is that planets can be ejected from their home systems due to gravitational interactions with larger bodies. This process, known as planetary scattering, is believed to have played a major role in shaping the modern solar system. Some astronomers suspect that early in its history, our solar system may have contained additional large planets that were either destroyed or flung into interstellar space. If a large planet was ejected, where would it be now? Could it be drifting unseen in the vast darkness between stars? Some researchers have proposed that these so-called rogue planets might still exist and that some could even host their own internal heat sources, potentially allowing subsurface oceans or other conditions suitable for life. The discovery of such a planet, especially one that was once part of our solar system, would be a groundbreaking revelation. The idea that planets can be lost to interstellar space also raises the question of whether our solar system has ever gained planets from elsewhere. If a rogue planet passed close enough to the Sun, could it have been captured by our solar system's gravity? Some astronomers have speculated that certain Kuiper belt objects, including Pluto-sized bodies, may have originally formed around other stars before being captured by the Sun. If this is true, then some of the forgotten planets of our solar system may not be lost worlds, but adopted ones. The possibility of planetary capture has led scientists to rethink the definition of what constitutes a planet. Traditionally, a planet is defined by 3 criteria. It must orbit the Sun, have enough mass to be rounded by its own gravity, and have cleared its orbit of debris. However, if we consider captured planets, this definition becomes complicated. Would a captured rogue planet qualify as an official member of our solar system, or would it remain an outsider, a cosmic wanderer merely passing through? The presence of such a planet could explain some of the gravitational anomalies observed in the outer solar system. If a large body were lurking beyond Neptune, it could be responsible for the unusual orbits of some trans-Neptunian objects. Some astronomers believe that a hidden super-Earth, or even a gas giant, could be out there, just waiting to be discovered. Another mystery that ties into the search for forgotten planets is the question of why our solar system lacks a planet in the size range between Earth and Neptune. Many exoplanetary systems contain super-Earths, planets larger than Earth but smaller than Neptune, yet our solar system seems to be missing one. Some scientists speculate that a super-Earth might have once existed here but was either ejected, destroyed, or absorbed by a larger planet during the early chaotic stages of planetary formation. If such a planet once existed, it could help explain certain anomalies in the distribution of mass within the solar system. For instance, the gap between Mars and Jupiter is unusually large compared to the gaps between other planets. Some researchers suggest that a missing super-Earth might have once occupied this region before being disrupted by Jupiter's gravity. If true, this could mean that the asteroid belt is not just a failed planet, but the remains of a once thriving world. Beyond the asteroid belt, the Kuiper belt and Oort cloud continue to pose deep mysteries. Some of the most distant objects in the solar system exhibit orbits that seem to be influenced by an unseen gravitational force. This has led to speculation that there could be not just one, but multiple undiscovered planets in the outer reaches of the solar system. If such planets exist, they may be incredibly difficult to detect. The farther a planet is from the Sun, the less light it reflects, making it nearly invisible to traditional telescopes. However, upcoming advancements in infrared astronomy may provide new ways to detect these hidden worlds. Infrared telescopes can detect the faint heat signatures of distant objects, even those that receive little to no sunlight. The search for these forgotten planets has also led to unexpected discoveries about the nature of planetary formation itself. In recent years, astronomers have found evidence that planets can form in a variety of ways, not just through the gradual accumulation of dust and gas. Some planets may form from the direct collapse of gas clouds, while others may emerge through the collision and merger of smaller planetary bodies. These discoveries challenge our understanding of how the solar system evolved. If planets can form and be destroyed through such dynamic processes, then it is entirely possible that our solar system once contained more planets than it does today. Some of these planets may have been lost to the chaos of early formation, while others may still be out there, hidden in the darkness. This raises an even more profound question: what does it mean for a planet to be forgotten? If a planet is ejected from the solar system, does it cease to be part of our cosmic story? Or do its gravitational echoes still shape the orbits of the remaining planets, serving as a silent reminder of its lost existence? The study of these forgotten planets is more than just an academic exercise. It is a way of piecing together the deep history of our cosmic home. As technology advances, we may one day find definitive evidence of these lost worlds, whether in the form of direct observations, gravitational imprints, or even ancient planetary debris scattered throughout the solar system. Until then, the search continues. Every telescope scan, every new space probe, and every unexplained gravitational anomaly brings us closer to uncovering the full story of the solar system. The forgotten planets may not remain forgotten forever. One day, they may reveal themselves, reshaping everything we thought we knew about our place in the cosmos. The possibility of forgotten planets lurking in the dark recesses of the solar system challenges the way we perceive our cosmic neighborhood. What if our solar system is not a static system with a fixed number of planets, but a dynamic, evolving place where planets have come and gone over billions of years? This idea may seem radical, but the evidence supporting it continues to grow. One of the strongest arguments for the existence of missing or undiscovered planets is the gravitational anomalies observed in the outer solar system. While most known objects follow predictable orbits dictated by Newtonian physics and Einstein's theory of general relativity, certain trans-Neptunian objects, TNOs, behave in ways that suggest an unseen gravitational influence. Their elongated orbits, unusual clustering, and unexplained tilts all hint at something massive lurking beyond our current observational limits. Planet 9 is the leading hypothesis to explain these anomalies, but what if there is more than one hidden planet? Some researchers argue that the patterns observed in the Kuiper Belt and Oort cloud suggest the influence of multiple large bodies. These planets, if they exist, would be so distant and faint that they remain beyond the reach of our current telescopes. However, upcoming missions and advancements in infrared astronomy could change that. The Vera C. Rubin Observatory, set to begin operations in the coming years, will conduct an unprecedented sky survey that may finally detect the elusive Planet 9, or reveal an entirely new class of planetary objects in the outer solar system. If one or more of these forgotten planets are found, it could redefine our understanding of planetary systems not just in our solar system but across the galaxy. But what if some of these planets are not merely hidden but truly lost? Astronomers have long theorized that rogue planets, worlds that have been ejected from their home systems, may outnumber stars in the galaxy. If our solar system once had additional planets, at least one or more could have been thrown into interstellar space. If so, these planets may still be wandering through the void, drifting between the stars in perpetual darkness. Rogue planets are particularly interesting because they challenge our assumptions about planetary habitability. Traditionally, we think of habitable planets as those orbiting within the so-called Goldilocks zone, the region around a star where conditions allow liquid water to exist. However, some theories suggest that rogue planets could retain subsurface oceans, kept warm by internal heat generated from radioactive decay or residual formation heat. If this is true, then even an ejected planet could potentially harbor life, surviving in a way that defies our current models. This raises another question: could a rogue planet, once part of our solar system, have seeded life elsewhere in the galaxy? The idea of panspermia, the hypothesis that life can be transferred between planets or even between star systems, suggests that microbial life could survive impact events, be carried into space on planetary fragments, and potentially take root elsewhere. If a forgotten planet from our solar system was ejected and later captured by another star, it could have carried life with it, spreading the biological legacy of our solar system to an entirely different part of the universe. Such a scenario may sound like science fiction, but recent discoveries have made it more plausible. Studies of extremophiles, organisms that can survive in extreme conditions, have shown that life can endure the harsh environment of space for extended periods. If microbial life could survive interstellar travel, then the forgotten planets of our solar system might not only be lost worlds but potential cradles of life in distant corners of the galaxy. But while some planets may have been lost, others may have been gained. The idea that our solar system might have captured planets from interstellar space is not far-fetched. Observations of exoplanetary systems have shown that planetary migration is common, with planets frequently being ejected and sometimes captured by other stars. If our solar system has ever captured a planet, it may not be immediately obvious. A captured planet would likely have a highly elliptical orbit or an unusual inclination compared to the other planets. Some astronomers have speculated that certain Kuiper Belt objects, including Sedna and other distant planetoids, might be captured objects from another star system. Their highly elongated orbits and unusual trajectories suggest that they may have originated elsewhere before being trapped by the Sun's gravity. If true, this would mean that our solar system is not just a closed system but one that has exchanged planetary material with the rest of the galaxy. This idea aligns with what we now know about interstellar objects like Oumuamua and Borisov, both of which pass through our solar system from other stars. These objects suggest that interstellar exchanges of material are more common than previously thought. If small objects like comets and asteroids can travel between star systems, why not planets? If we have captured planets from other star systems, what would they be like? Would they resemble the known planets of our solar system, or would they be entirely different? Could a captured planet still harbor traces of its original star system, such as a unique chemical composition or an unusual atmospheric makeup? The implications of such a discovery would be profound. If we were to find a captured exoplanet within our own solar system, it could provide direct evidence of planetary migration between stars. This would support the idea that planetary systems are not isolated but interconnected, exchanging worlds across vast cosmic distances. As our technology improves, our ability to detect these forgotten planets will only increase. Future telescopes and space probes may provide definitive answers to the questions that have puzzled astronomers for centuries. Whether through direct observation, gravitational analysis, or even potential interstellar missions, we may one day confirm the existence of lost worlds, some that were once part of our solar system and others that joined us from the depths of space. The search for forgotten planets is not just about filling gaps in our planetary census. It is a journey toward understanding the forces that shape planetary systems, the possibility of life beyond Earth, and our place in the cosmic web. Every new discovery brings us closer to answering some of the most profound questions in astronomy. What other secrets are hidden in the darkness beyond Neptune? Could an ancient, forgotten world still be out there, waiting to be rediscovered? Or have we already encountered interstellar travelers, planets that once belonged to other stars but now orbit our sun in silence? These mysteries remind us that even within our own solar system, the unknown far outweighs the known. The forgotten planets may not remain forgotten forever. One day, they may return to our awareness, reshaping everything we thought we knew about the history and future of our cosmic home. The search for forgotten planets is far from over, and as technology advances, the possibility of discovering long-lost worlds becomes ever more likely. But beyond scientific discovery, the idea of missing planets forces us to rethink what we know about the history of our solar system. Have we underestimated the chaotic past of our planetary neighborhood? Have entire worlds formed, evolved, and disappeared without leaving a trace? One of the most intriguing aspects of this search is the question of planetary ejection. While we tend to think of planets as stable entities that remain bound to their stars, simulations suggest that planetary systems often go through violent reshuffling events. In the early solar system, gravitational interactions between forming planets likely resulted in some being thrown out entirely. This means that our solar system could have once had additional planets that were expelled into deep space, leaving behind only subtle clues of their existence. But what if not all of these planets were entirely ejected? Some astronomers speculate that certain celestial bodies, like Sedna, a distant trans-Neptunian object with an extremely elongated orbit, may have once been planets that were partially ejected but remained loosely bound to the Sun. These objects could be remnants of a long-lost planet that was disrupted by a massive gravitational encounter, perhaps with Jupiter or another large body. Even more mysteriously, some scientists propose that our solar system may have once had a second star. This idea, often referred to as the Nemesis hypothesis, suggests that the Sun could have had a companion star in the distant past. If true, this could have influenced planetary orbits in ways we have yet to fully understand. A companion star might have helped clear out certain regions of the solar system, ejecting planets, or even causing disruptions in the Kuiper belt and Oort cloud. While no evidence for Nemesis has been found, the possibility remains open, and ongoing surveys continue to search for faint, distant objects that could support this idea. Another fascinating possibility is that some of the forgotten planets were destroyed rather than ejected. While we see the planets in our solar system as stable today, early planetary formation was a much more chaotic and violent process. Collisions between protoplanets were common, and some scientists believe that a massive planetary collision led to the formation of the Moon. Could other planets have met a similar fate? One theory suggests that a large planet once existed between Mars and Jupiter but was destroyed in a catastrophic impact, leaving behind what we now call the asteroid belt. While this idea has largely been replaced by the understanding that the asteroid belt consists of leftover material that never formed into a planet, the possibility of a destroyed planet still lingers in certain astronomical discussions. If a past planetary collision was violent enough, it might have shattered a world completely, dispersing its remains into the depths of space. The same question applies to hypothetical planets like Vulcan. Originally proposed as an inner planet closer to the Sun than Mercury, Vulcan was believed to exist due to unexplained deviations in Mercury's orbit. However, no such planet was ever found, and Einstein's theory of general relativity later provided an explanation for Mercury's motion without the need for an additional planet. But what if Vulcan did exist in the distant past? Could a close encounter with another body or even a collision with the Sun have erased it from existence? Similarly, Planet X was long hypothesized to explain discrepancies in the orbits of Neptune and Uranus. While this concept has largely been replaced by the modern search for Planet 9, the idea of undiscovered massive planets still lingers. If a large planet once existed in the outer solar system but was ejected or fragmented, it could explain some of the anomalies that continue to puzzle astronomers today. One of the greatest challenges in searching for forgotten planets is the vastness of space itself. Even within our own solar system, distances are immense, and faint objects are difficult to detect. The farther a planet is from the Sun, the less light it reflects, making it nearly invisible to traditional optical telescopes. This is why new observational techniques, such as infrared surveys and gravitational mapping, are so critical to the hunt for lost worlds. Gravitational lensing, for example, is a method that allows astronomers to detect massive objects by observing how they bend light from distant stars. If a large, unseen planet exists in the far reaches of the solar system, its gravity could subtly distort the light from background stars, revealing its presence even if it remains invisible through traditional means. Another promising technique involves the study of Kuiper belt objects and their orbital patterns. If multiple distant objects share unusual orbital characteristics, it could indicate the gravitational influence of a hidden planet. This is the primary method being used in the ongoing search for Planet 9, but it could also uncover other, previously unknown planets. Beyond our solar system, the discovery of exoplanets has opened an entirely new frontier in planetary science. The fact that we now know of thousands of planets orbiting other stars has forced astronomers to rethink what is possible within our own system. If exoplanetary systems can contain massive planets in unusual orbits, rogue planets drifting through interstellar space, and worlds vastly different from those in our solar system, then why wouldn't our own system have had a more complex history than we once assumed? The forgotten planets of our solar system may not remain forgotten forever. With each technological advancement, we move closer to unlocking the secrets of our cosmic past. The history of planetary formation, migration, and destruction is far from settled, and as new evidence emerges, our understanding of the solar system's past will continue to evolve. The search for missing planets is about more than just filling in gaps in our astronomical knowledge. It is a quest to understand how planetary systems form, how they change over time, and how they interact with the wider galaxy. If we can uncover the lost worlds of our own solar system, we may gain insights into planetary evolution that apply not only to our own cosmic neighborhood but to planetary systems across the universe. What if one day we finally detect the unmistakable signature of a long-lost planet? What if an object once thought to be a mere asteroid turns out to be a fragment of an ancient world? What if the next great astronomical discovery is not in a distant exoplanetary system but right here, hidden in the shadows of our own backyard? The answers may be closer than we think. As we continue to explore, observe, and question, we may one day uncover the forgotten planets, revealing a solar system far more dynamic and mysterious than we ever imagined. The search for forgotten planets is not just a historical curiosity. It is an ongoing mission that could redefine our understanding of the solar system's past and future. What if our current model of planetary formation is incomplete? What if there are more missing pieces to the grand puzzle of our cosmic neighborhood? With each passing year, new discoveries challenge the old paradigms, revealing that our solar system may have undergone dramatic changes over billions of years, changes that could have erased entire worlds from existence. One of the most compelling reasons to believe in lost planets is the sheer number of exoplanets we've discovered. When astronomers first started detecting planets beyond our solar system in the 1990s, they expected to find worlds similar to those in our own backyard: rocky inner planets, gas giants further out, and a neat, orderly structure. Instead, what they found was chaos. There were hot Jupiters, massive gas giants orbiting perilously close to their stars. There were super-Earths, planets larger than our own but smaller than Neptune, a type of world that doesn't even exist in our solar system. There were planetary systems where multiple gas giants coexisted in tight orbits, something thought impossible based on our own system's dynamics. If other planetary systems can be so radically different, what does that say about the past of our own solar system? Could our planetary arrangement be the result of a much more complex history, one where multiple worlds formed, migrated, and were either destroyed or cast away? The idea of forgotten planets no longer seems far-fetched. It seems almost inevitable. The search for these lost worlds is now being pursued through multiple methods. One of the most promising avenues is the study of unusual orbits. Take, for example, the strange case of Sedna, a distant object that follows an incredibly elongated path around the Sun, never coming close enough to be influenced by the known planets, yet too far to have been affected by the Sun's gravitational pull alone. What could have caused such an orbit? Some astronomers believe that a missing planet, one that was once part of the solar system but is no longer there, may have pulled Sedna onto its bizarre trajectory before vanishing from sight. A similar mystery surrounds the orbits of some Kuiper belt objects. Their paths suggest the gravitational influence of a massive, unseen body, something large enough to affect their movement but invisible to our telescopes. This is one of the strongest pieces of evidence in favor of the so-called Planet 9 hypothesis. While it remains unconfirmed, the possibility that a giant world lurks in the dark reaches of the solar system is one of the most exciting prospects in modern astronomy. If Planet 9 exists, it would be a literal, forgotten planet, one that formed alongside the others but was banished to the farthest regions of space, where it has remained undetected for billions of years. But what about planets that were not merely exiled but completely destroyed? There are reasons to believe that violent collisions may have played a major role in shaping the solar system we see today. The leading theory for the formation of Earth's moon is that a Mars-sized body, often called Theia, slammed into the young Earth, ejecting massive amounts of debris that eventually coalesced into the moon. But what if Theia wasn't the only lost world? What if other collisions took place in the early solar system, obliterating entire planets and scattering their remains into space? Some astronomers speculate that the asteroid belt between Mars and Jupiter is not just a collection of leftover planet-forming material, but the remnants of a destroyed world. The idea of a missing planet in that region has been around for centuries, but modern research suggests that the gravitational influence of Jupiter likely prevented a planet from ever forming there. However, if a planet did form and was later shattered by an impact, it would explain why the asteroid belt is composed of such varied materials, including metallic cores that hint at the existence of a once differentiated planetary body. Another area of interest is Mercury, the smallest and densest of the inner planets. Mercury's composition is unusual. It has a disproportionately large iron core relative to its size, suggesting that it may have once been a much larger planet that lost its outer layers in a catastrophic collision. If so, could this mean that an entire world once existed in the inner solar system, only to be reduced to a fraction of its original size? Could that planet have been Vulcan, the hypothetical world once believed to orbit even closer to the Sun? While Vulcan was disproven in the 20th century, its origins as a theoretical planet were based on real anomalies in Mercury's orbit. What if those anomalies were the lingering scars of a lost planet's destruction? Even further out, the idea of missing planets extends to the edge of the solar system. The Oort cloud, a vast sphere of icy bodies surrounding our system, is home to countless comets that occasionally make their way toward the Sun. Some of these comets have highly unusual orbits that are difficult to explain through known gravitational influences. Could an undiscovered planet in the distant solar system be responsible? Could the hypothetical Nemesis star, a long-lost companion to the Sun, have once existed and altered the structure of the outer solar system before drifting away or being lost to time? The idea of a missing twin to our Sun is one of the most controversial theories in astronomy, but it is not without merit. Many stars in the galaxy are part of binary or multiple star systems, meaning that single star systems like our own are actually less common than we once believed. If the Sun did have a companion in the past, its gravitational influence could have drastically reshaped planetary orbits, causing ejections, disruptions, and even the disappearance of entire worlds. While no direct evidence for Nemesis has been found, its potential existence continues to fuel discussions about the true history of the solar system. The quest for lost planets is, in many ways, a search for our own origins. Understanding the forgotten worlds of our past may reveal why the planets are arranged the way they are, why Earth became habitable, and why life emerged here but seemingly nowhere else in our system. It may even help us predict the future. Will our solar system remain stable, or could new planetary reshuffling events occur, leading to the exile or destruction of existing worlds? As our telescopes grow more powerful and our methods more precise, we inch closer to uncovering the secrets of these forgotten planets. Whether through the detection of faint gravitational disturbances, the discovery of long-hidden planetary fragments, or the identification of rogue worlds that may have once belonged to our system, the evidence is building. One day, we may finally confirm the existence of a lost planet, perhaps a massive ice giant lurking in the darkness, or the shattered remnants of a world that once thrived where only asteroids remain today. Until then, the mystery of the forgotten planets remains one of the most tantalizing puzzles in astronomy. Were these planets real? Were they lost to time, erased by collisions, exiled into the void, or swallowed by the Sun itself? The answer may still be out there, waiting to be found in the depths of space, hidden in the silent echoes of the solar system's forgotten past. The search for forgotten planets is not just about reconstructing the past, it's about understanding the forces that continue to shape our solar system today. If planets were once lost, what does that mean for the future? Could our solar system still be undergoing slow, invisible changes that will one day lead to the disappearance or exile of yet another world? The more we study, the more we realize that planetary systems are dynamic, chaotic places, where nothing remains static forever. One of the most compelling arguments for the existence of lost planets comes from the strange and often unexpected behavior of small objects in the outer solar system. Consider Sedna, a dwarf planet that orbits the Sun at an extreme distance. Its orbit is so elongated that it takes more than 11,000 years to complete a single revolution. What force could have placed it on such a bizarre path? Some scientists believe that only the gravitational influence of a massive, unseen world, perhaps a long-lost planet, or even a hidden star, could explain Sedna's strange trajectory. This ties directly into the ongoing hunt for Planet 9, a hypothetical giant world lurking far beyond Neptune. The evidence for Planet 9 comes from the unusual clustering of trans-Neptunian objects, icy bodies that orbit in a way that suggests they are being shepherded by the gravity of something much larger. If Planet 9 exists, it may be a remnant of a past planetary system, one that either formed in our solar system and was exiled, or perhaps even an interstellar rogue planet that was captured by the Sun's gravity billions of years ago. But what about even older planets, ones that may have been destroyed completely? The early solar system was a violent place, filled with collisions and gravitational disruptions. We see evidence of this in craters on the Moon, Mars, and Mercury, as well as in the asteroid belt. Could one of these impacts have obliterated an entire world? Some researchers believe that a fifth terrestrial planet once existed between Mars and Jupiter, only to be shattered by a cataclysmic event. The asteroid belt, rather than being simply leftover debris from planetary formation, could be the remnants of this destroyed planet. This theory, often referred to as the Missing planet hypothesis suggests that gravitational interactions with Jupiter may have destabilized this hypothetical world's orbit, leading to a collision that shattered it into countless fragments. If this is true, then pieces of this lost planet may still exist today, scattered across the asteroid belt, hidden within meteorites that occasionally fall to Earth, or even buried beneath the surfaces of other planets where debris from the impact may have landed. Some astronomers speculate that the solar system may have once had an additional gas giant. This hypothetical world, sometimes referred to as Planet V, is thought to have formed in the early solar system before being ejected due to gravitational interactions with Jupiter and Saturn. If true, this means that our current planetary lineup is not the original arrangement of the solar system. Instead, we may be looking at a system that once had more planets, but where some were lost due to gravitational instability. This idea is supported by computer simulations that suggest our solar system is missing a planet. When astronomers run simulations of how the solar system formed, they often find that a planetary ejection event is necessary to produce the system we see today. If our solar system originally had 5 giant planets instead of 4, then one of them, possibly a Neptune-sized world, was flung into interstellar space, never to be seen again. If this happened once, could it happen again? Could one of our current planets be at risk of ejection? The answer is complicated. While the solar system is currently stable, gravitational interactions are unpredictable over long timescales. If an outside force, such as a passing star, were to disturb the delicate balance, it's not impossible that a planet could be thrown into a chaotic orbit, eventually being exiled into deep space. This raises another fascinating question. If planets can be ejected from solar systems, where do they go? The answer lies in the concept of rogue planets, worlds that drift through interstellar space, untethered to any star. These planets may have been exiled from their home systems billions of years ago, condemned to wander the darkness forever. Some scientists believe there may be more rogue planets in the galaxy than there are stars, meaning that planetary ejection is not a rare event, but a common one. If our solar system once had lost planets, could they still be out there? Could a former member of our planetary family be drifting through space, unnoticed and forgotten? Some astronomers think it's possible, and future telescopes may be able to detect such a world, perhaps by observing the faint heat signature it gives off as it cools, or by detecting how it interacts with the interstellar medium. There is also the possibility that lost planets still exist within our solar system, hidden in the darkness beyond the Kuiper belt. The Oort cloud, a vast shell of icy objects surrounding the solar system, is so far away that we have never directly observed most of its contents. If a lost planet were lurking in this region, it could remain undetected for centuries. Some theories even suggest that the Sun could have captured an exoplanet from another star system at some point in its history, meaning that our solar system may contain a foreign world that never belonged here in the first place. Another angle to consider is the fate of inner planets. If Mercury truly is the remnant of a once larger world, could a similar fate await Venus or Earth? Over billions of years, planetary collisions, atmospheric stripping, and other cosmic events could radically change the structure of our solar system. In the distant future, could Earth itself become a forgotten planet, known only through traces left behind in the ruins of the Moon or Mars? The idea of forgotten planets forces us to rethink what it means for a world to exist in the long term. Planets are not static. They are dynamic objects that can form, evolve, and even disappear over time. Some may be lost to cataclysms, while others may be cast into the void, never to be seen again. Some may even have been destroyed in ways we have yet to discover, perhaps by forces we do not yet understand. As we continue to explore space, we may one day uncover definitive proof of these missing worlds. Whether through the discovery of Planet 9, the detection of an ejected rogue planet, or the identification of planetary remnants buried deep within our own system, the search for forgotten planets is far from over. What we do know is that our solar system is far more complex than we once believed. It is not just a collection of 8 planets moving in perfect harmony. It is a place of change, mystery, and lost history. There may be worlds we will never know about, stories of destruction and exile that remain hidden in the depths of space. But if history has taught us anything, it is that the universe rarely keeps its secrets forever. The mystery of the forgotten planets may yet be solved, revealing a hidden chapter in the story of our cosmic neighborhood. And when that day comes, we may finally understand the true nature of the solar system, not as a static, unchanging place, but as a living, evolving entity, shaped by forces far greater than we ever imagined. The search for forgotten planets is not just an exploration of our solar system's past, it's a glimpse into the potential future of planetary science. If planets have been lost before, what does that mean for the stability of the solar system? Are there still unknown forces at play that could reshape our cosmic neighborhood? And most intriguingly, if these planets were truly forgotten, could there be evidence of their existence hidden in plain sight? One of the most compelling arguments for lost planets comes from the anomalies we see in the outer solar system. The behavior of distant objects like Sedna, with its extreme orbit, suggests that something massive may have influenced it. Could a forgotten planet, long since ejected or hidden in the darkness, still be affecting the solar system in subtle ways? Astronomers continue to analyze these gravitational oddities, hoping to uncover the presence of a world that was never officially recognized. The case of Planet 9 remains one of the greatest modern mysteries in planetary science. The idea that a super-Earth-sized planet lurks beyond Neptune has gained traction due to the peculiar clustering of trans-Neptunian objects. These icy bodies appear to move in a way that implies they are being shepherded by a larger gravitational force. While no telescope has yet confirmed Planet 9's existence, the evidence suggests that something massive, perhaps a world that formed early in the solar system and was later displaced, could still be out there, hidden in the void. If Planet 9 is ever discovered, it would fundamentally change our understanding of planetary dynamics. It would confirm that our solar system's history is far more turbulent than we once believed, with planets shifting, migrating, and even disappearing over time. This could also provide insight into how other planetary systems evolve. If our system has lost planets, then exoplanetary systems around other stars might have undergone similar changes, meaning that planetary loss and migration could be a common cosmic phenomenon. But what if some forgotten planets didn't simply disappear? Could they have left behind remnants that we have yet to recognize? The asteroid belt is often cited as the potential remains of a destroyed planet. Some researchers propose that a once fully formed world existed between Mars and Jupiter, only to be shattered by a catastrophic collision. While the traditional view is that the asteroid belt consists of primordial material that never formed a planet, the possibility that it is a graveyard of a lost world remains open for debate. If a planet was once there, it may have contained geological and atmospheric features unlike anything else we have seen. Could meteorites on Earth contain hidden clues, pieces of a planetary crust from a world that no longer exists? Even more fascinating is the idea that planetary destruction is not a rare event. The early solar system was a chaotic place, filled with massive impacts and shifting orbits. Some researchers speculate that Earth itself may have once been part of a binary planetary system, perhaps with a twin planet that was later destroyed or absorbed in a violent collision. The Moon is believed to have formed from a massive impact between Earth and a Mars-sized body. But what if that body wasn't just a rogue protoplanet? What if it was a true, fully developed planet that met a tragic end? This brings us back to another long-standing mystery, Nemesis, the hypothetical companion star to the Sun. For years, scientists speculated that a faint, red or brown dwarf could be orbiting the Sun at an extreme distance, periodically disturbing the Oort cloud and sending comets hurtling toward the inner solar system. While no direct evidence of Nemesis has been found, the idea is still debated. Some astronomers believe that the periodic mass extinctions on Earth, such as the one that wiped out the dinosaurs, could be linked to cometary bombardments triggered by an unseen gravitational influence. If Nemesis were real, it would mean that our solar system has a far more complex structure than we currently understand. And if Nemesis was once part of our system but has since drifted away, it could mean that our Sun was once part of a binary system, a common occurrence among stars. If true, then the Sun's history is far more mysterious than we realize. It would also raise questions about what happened to the hypothetical planets that may have once orbited Nemesis. Could they still exist somewhere, perhaps as rogue planets wandering the galaxy? The study of forgotten planets also extends beyond the solar system. The discovery of rogue planets, planets that drift through space without a star, suggests that planetary ejection is more common than we previously thought. Some of these planets may have formed in other solar systems before being thrown out due to gravitational disruptions. If this process happened in our own system, then it is possible that a lost planet from our past is still traveling through interstellar space, unseen and unknown. What if a lost planet were to return? While it may seem unlikely, the chaotic nature of gravity means that nothing is entirely predictable over billions of years. If a planet were ejected early in the solar system's history, it might have been captured by another star's gravity. However, if it remained in a highly elliptical orbit around the Sun, there is a possibility that it could one day return, plunging back into the solar system after an absence of millions or even billions of years. If this were to happen, it could cause enormous disruptions. The gravitational pull of a returning lost planet could send asteroids hurtling toward the inner solar system, potentially triggering mass extinctions. It could destabilize the orbits of the outer planets, leading to further chaos. While such a scenario is highly speculative, it is not beyond the realm of possibility. After all, we are only just beginning to understand the long-term evolution of planetary systems. There is also the possibility that some lost planets still exist within the solar system, hiding in the darkness. The Oort cloud, which lies far beyond Pluto, is so vast that we have never been able to observe most of its contents. If a planet were lurking there, it could remain undetected for centuries. Some theories suggest that a hidden ice giant, or even a captured exoplanet, could be concealed in this region, waiting to be discovered by future telescopes. The idea of forgotten planets forces us to rethink everything we know about planetary science. Planets are not static, unchanging objects. They are dynamic entities that can be formed, destroyed, or exiled. If planets have been lost before, it is possible that the solar system as we know it is only a temporary arrangement. Over billions of years, the lineup of planets may continue to shift, with new worlds forming and old ones vanishing into the darkness. As technology advances, we may finally uncover the truth about these forgotten worlds. Whether through the discovery of a lost planet in the Oort cloud, the identification of planetary remnants in the asteroid belt, or even the detection of a rogue planet that once belonged to our system, the search is far from over. The universe is full of hidden histories, and as we continue to explore, we may one day piece together the lost chapters of our solar system's story. The mysteries of space are endless, and the forgotten planets are just one piece of the puzzle. The more we learn, the more we realize that the universe is far stranger, more dynamic, and more unpredictable than we ever imagined. And as we continue to look deeper into the cosmos, we may one day find that the planets we thought were lost were never truly gone. They were just waiting to be found again. The search for forgotten planets is more than just an attempt to reconstruct the past. It is a reflection of how little we truly understand about planetary formation, migration, and destruction. If planets have disappeared, it means they were either destroyed, ejected, or hidden in ways we have yet to comprehend. The implications stretch far beyond our solar system, influencing how we view planetary evolution throughout the cosmos. Could our solar system be just one of many where planets have been lost to time? And if so, what does that say about the nature of planetary systems in general? One of the most intriguing possibilities is that some of these lost planets were not merely casualties of cosmic forces but rather remnants of an earlier stage of the solar system's history, one far more chaotic than we can imagine. In its infancy, the solar system was not the orderly arrangement of planets we see today. Instead, it was a violent, ever-changing battlefield where young planets collided, merged, or were ejected entirely. Astronomers theorize that many planetary embryos formed alongside the ones that became our current planets, but only a few survived the relentless gravitational battles that shaped our system. This raises a fascinating question: what if Earth itself was once in a very different planetary lineup? If other planets existed in our solar system's past, they may have had their own moons, atmospheres, and possibly even conditions that could have supported life before being lost to time. Some theories suggest that early Mars was once in a more habitable region of the solar system before drifting to its current position. If planetary migration played a major role in the past, then forgotten planets may have once occupied regions where we least expect them today. Consider the case of Theia, the Mars-sized body that is believed to have collided with Earth and contributed to the formation of the Moon. While most models describe Theia as a protoplanet that formed in Earth's neighborhood, some researchers believe it could have been a fully formed, independent planet that was later destroyed in this cataclysmic impact. If this is true, Theia might have had its own geological history, potentially even its own moons, before its existence was violently erased. The Moon itself may hold traces of Theia's original composition, meaning that fragments of a lost world still linger in our night sky. But what if Theia wasn't the only planet to meet such a fate? Given the number of planetary embryos that likely formed in the early solar system, it is possible that several large planetary bodies once coexisted with Earth, only to be obliterated or absorbed over time. The remnants of these worlds could be scattered throughout the asteroid belt, buried within the rocky surfaces of other planets, or even hidden deep within Earth's own mantle, having merged with our planet long ago. The idea that planetary remains are still present in the solar system is supported by strange meteorite discoveries. Some meteorites that have fallen to Earth contain isotopic compositions that don't quite match any known planetary body, suggesting that they could be pieces of a world that no longer exists. Could we be unknowingly collecting fragments of forgotten planets, pieces of a history that has been erased by time? Beyond the asteroid belt, the Kuiper belt and Oort cloud may hold even more secrets. These regions, which extend far beyond the orbits of the known planets, are filled with icy bodies and dwarf planets that have barely been explored. Some scientists speculate that a large, undiscovered planet could be lurking in this distant realm, hidden in the darkness where our current telescopes have yet to reach. If such a planet exists, it may be a true relic of the past, a world that formed alongside Neptune and Uranus but was cast out into the fringes of the solar system during a period of instability. Alternatively, it could be a captured rogue planet, an interstellar wanderer that was drawn in by the sun's gravity, and has remained hidden ever since. If we were to find such a world, it would change everything we know about planetary dynamics. The concept of rogue planets adds yet another layer of mystery to the idea of lost worlds. Astronomers have discovered that there are likely more rogue planets in the galaxy than there are stars, meaning that planetary ejection is a far more common event than we once believed. Some of these planets may have originated in solar systems like ours, only to be flung into interstellar space due to gravitational disruptions. If our solar system has lost planets in the past, some of them may now be drifting through the void, cold and alone, without a star to call home. But what if a lost planet were to return? While it may seem unlikely, gravitational interactions can be unpredictable over long timescales. If a planet were ejected with just the right trajectory, it could theoretically return after millions or even billions of years. If such an event were to occur, it could have devastating consequences. A returning planet could destabilize the orbits of existing worlds, send asteroids hurtling toward Earth, or even become a new addition to the solar system, reshaping our cosmic landscape. The possibility of hidden planets also extends to the search for Nemesis, the hypothetical companion star to the Sun. While no direct evidence has been found, the idea of a distant, faint companion star is still considered plausible. If Nemesis exists, it could mean that our solar system was once part of a binary system, a common occurrence among stars. If so, the presence of an additional gravitational force could explain some of the anomalies we see in the outer solar system, including the strange orbits of certain distant objects. Even if Nemesis itself is never found, the idea that our solar system may have had a more complex history than we currently understand is worth exploring. Some theories suggest that our Sun may have captured planets from other star systems during its journey through the galaxy. If this is the case, then some of the worlds in our solar system may not have originally formed here at all. Ultimately, the search for forgotten planets is a journey into the unknown, one that forces us to question everything we think we know about the solar system. If planets have come and gone before, what does that mean for the future? Will the current arrangement of planets remain stable, or will new planetary migrations occur in the distant future? Could Earth itself one day be displaced, becoming a lost world in its own right? As technology advances, our ability to detect hidden planets improves. The next generation of telescopes may finally reveal the presence of Planet 9, uncover new dwarf planets in the Kuiper Belt, or even detect a rogue planet that was once part of our solar system. The mysteries of space are far from solved, and the forgotten planets may yet have their stories told. With every discovery, we come closer to understanding the full history of our cosmic neighborhood. And perhaps, one day, we will uncover the truth about the planets that time forgot, the worlds that shaped our solar system, only to disappear into the darkness, waiting for us to find them again. The search for forgotten planets is not just about uncovering the past, it is about understanding the future of our own solar system. If planets have been lost before, what prevents it from happening again? Could Earth itself one day become a relic of a bygone cosmic arrangement? These questions take us into the realm of planetary evolution, gravitational chaos, and the unseen forces that have shaped our solar system in ways we are only beginning to understand. One of the most compelling theories about planetary loss involves the idea of orbital resonance and gravitational instability. In the early solar system, planets did not follow the orderly paths they do today. Instead, they were locked in a chaotic dance, their orbits shifting due to the gravitational influences of neighboring worlds. When two planets fall into a resonance, a situation where their orbits synchronize in a way that amplifies their gravitational interactions, it can lead to extreme disruptions. Some planets may get ejected entirely, while others may be pushed into highly elliptical orbits, where they eventually collide with another planet or fall into the Sun. This process may have played a key role in the disappearance of hypothetical planets like Planet V, a proposed planet that some scientists believe once orbited between Mars and the asteroid belt. Some studies suggest that an additional planet in this region could have been gravitationally unstable, eventually breaking apart and forming the asteroid belt we see today. If this is true, then every asteroid in that region may be a remnant of a once fully formed world, shattered by gravitational chaos. The same fate may have befallen other theoretical planets in the distant reaches of our solar system. If a massive ice giant once existed beyond Neptune, it may have been ejected into interstellar space during a period of planetary migration. This would explain why Neptune and Uranus have such unusual compositions compared to Jupiter and Saturn. Some researchers believe that an additional ice giant was originally present in the early solar system, but a close encounter with Jupiter sent it hurtling into the abyss, never to return. If planets can be lost in such dramatic fashion, then it raises another question: could planets also be captured? Some astronomers believe that the solar system may have acquired planets from other star systems in the past. Given the Sun's long journey around the Milky Way, it is entirely possible that it has passed through regions where rogue planets were abundant. If one of these planets came close enough, the Sun's gravity could have pulled it into orbit, making it a member of our solar system. If this has happened before, then there may be worlds in our system that did not originate here at all. This theory is particularly intriguing when considering the strange orbit of Sedna, a distant trans-Neptunian object with an orbit that suggests it was influenced by forces beyond the solar system. Some scientists believe that Sedna's orbit could be the result of an encounter with another star in the Sun's past, perhaps even a star that had its own planetary system. If so, then Sedna and other objects like it could be interstellar immigrants, having once belonged to a different sun entirely. The idea of planetary capture ties into the ongoing search for Planet 9, the still hypothetical world that many believe lurks beyond Neptune. If such a planet exists, its highly elongated orbit suggests that it may not have formed in its current position. Instead, it may have been either ejected from the inner solar system or captured from another star. If we ever confirm the existence of Planet 9, it could change our entire understanding of how planets are lost and gained over cosmic time. But what about the possibility that planets are still disappearing today? While it is unlikely that a major planet like Earth or Jupiter will be ejected anytime soon, smaller bodies may still be at risk. Some studies suggest that over the next few billion years, gravitational interactions could destabilize the orbits of minor planets and even moons, sending them crashing into the Sun or out into space. If a rogue planet were to pass through the solar system, it could disrupt the delicate balance of planetary orbits, potentially leading to new planetary losses in the distant future. Another possibility is that some lost planets are not missing at all, but rather hidden in plain sight. Some scientists speculate that certain planets may have been mistaken for moons. For example, Titan, the largest moon of Saturn, is larger than the planet Mercury. If it orbited the Sun instead of Saturn, it would likely be classified as a planet in its own right. The same could be said for Ganymede, Callisto, and other large moons in the solar system. Perhaps in the distant past, these worlds were independent planets that were later captured by gas giants, effectively stripping them of their planetary status. If this is true, then the story of planetary loss may not always be one of destruction, it may also be one of transformation. A world that was once a planet may not have been lost, but merely reassigned to a new role, becoming a moon, an asteroid, or even a comet. This means that the history of our solar system may be far more dynamic than we currently understand, with planetary identities shifting over time. This possibility adds another layer of intrigue to the search for lost planets. If worlds can change roles, then perhaps some of the bodies we see today were once part of an entirely different arrangement. The planets we recognize now may not be the same planets that existed billions of years ago. Some may have merged, others may have migrated, and some may still be waiting to be discovered in the far reaches of the solar system. The mystery of forgotten planets is ultimately a story about the ever-changing nature of the cosmos. Nothing in space is truly permanent. Planets come and go, orbits shift, and new discoveries constantly reshape our understanding of the universe. As we continue to explore our cosmic neighborhood, we may one day uncover the full history of the planets that were lost, the ones that remain, and the ones that have yet to be found. If the history of the solar system is one of continuous transformation, then we must consider the possibility that planets are not just lost or captured but may also be hiding in ways we do not yet understand. Some of the most compelling theories suggest that entire planetary bodies could be obscured from our view, either due to their extreme distances, unconventional orbits, or even their physical properties that make them difficult to detect. This idea ties directly into the ongoing hunt for Planet 9, which has remained elusive despite strong evidence suggesting its existence. Planet 9 is theorized to be a massive world lurking beyond Neptune, its gravitational influence subtly affecting the orbits of smaller objects in the Kuiper belt. Yet, despite extensive sky surveys, no telescope has yet been able to pinpoint its exact location. One of the reasons for this could be that Planet 9, if it exists, may be incredibly faint. A distant ice giant or super-Earth-sized planet could have an extremely low surface temperature, emitting little to no infrared radiation, making it nearly invisible to current detection methods. It may also be located in an orbital plane that is tilted relative to the rest of the solar system, causing astronomers to overlook it in their searches. If this is the case, then Planet 9 is not necessarily lost, it is simply waiting to be found. But what if there are even stranger explanations? Some physicists have speculated that Planet 9 might not be a planet at all but rather a primordial black hole, a tiny, dense object that warps spacetime around it. If such a black hole were orbiting the Sun in the farthest reaches of the solar system, it would be nearly impossible to detect directly. Instead, astronomers would have to rely on indirect methods, such as looking for the way its gravity bends the light of distant stars. If this theory proves correct, then the search for missing planets could turn into something far more extraordinary: the discovery of an ancient black hole hiding within our own cosmic backyard. Beyond Planet 9, there is also the question of whether the solar system once contained even more planets that have since vanished. Theoretical models suggest that before the current arrangement of planets settled into place, there may have been additional terrestrial planets in the early inner solar system. These worlds could have collided with each other, merged into larger bodies, or been ejected entirely. Some researchers propose that Mars, in particular, may have once had a sibling planet that was destroyed in a massive impact, with its remnants now forming the Martian moons Phobos and Deimos. This raises an even larger question: Could Earth itself have had a twin? Some scientists believe that early in its history, Earth may have shared its orbit with another planet, much like how certain asteroids today share stable Lagrange points in Jupiter's orbit. If this hypothetical twin world existed, it may have eventually been thrown off course due to gravitational disturbances, either crashing into Earth or being sent into deep space. If remnants of such a world still exist, they could be hidden in the asteroid belt or among near-Earth objects, waiting for us to piece together their story. The idea that planets can disappear or be hidden in unexpected ways extends beyond just our solar system. When we look at exoplanetary systems around other stars, we see countless examples of planetary arrangements that defy expectations. Some stars have massive planets that orbit extremely close to them, known as hot Jupiters, while others seem to have missing planets where we would expect them to be. In some cases, it appears that entire planets have been consumed by their parent stars, leaving behind only traces of their existence in the form of chemical signatures in the star's atmosphere. If planetary loss is a common feature of star systems throughout the galaxy, then it stands to reason that the same forces that shape distant exoplanetary systems could also be at work in our own. This brings us back to the concept of Nemesis, the hypothetical companion star to the Sun that was once proposed as a reason for periodic mass extinctions on Earth. While Nemesis itself has never been found, the idea that the Sun may have had a companion in the past remains an open question. If the Sun was once part of a binary system, then the gravitational effects of a long-lost stellar sibling could have played a role in reshaping the solar system as we know it. Some astronomers believe that evidence for such a past companion may be hidden in the Oort cloud, the vast, distant region of icy bodies that marks the outermost edge of the solar system. If an ancient star once passed close enough, it could have perturbed the orbits of these icy bodies, sending some of them hurtling inward to become comets, while scattering others into deep space. If such an event occurred in the past, then it could help explain why some long-period comets seem to come from unusual trajectories, suggesting they were disturbed by an external force. Another possibility is that the missing planets of our solar system are not lost but merely waiting to be understood in new ways. Could there be entire planetary bodies hidden beneath the thick atmospheres of gas giants? Some scientists have speculated that beneath the dense clouds of Jupiter and Saturn, there may be solid planetary cores, possibly remnants of rocky worlds that were later engulfed by these massive planets. If this is the case, then the planets we see today may have once looked entirely different, having swallowed smaller planets in their early history. The search for lost planets is more than just an exercise in celestial archaeology. It is a quest to understand the fundamental processes that shape planetary systems across the universe. If we can determine how and why planets disappear, we may be able to predict the fate of our own world in the distant future. Will Earth remain in its current orbit for billions of years, or could gravitational forces eventually send it drifting into space? Could another planet one day emerge from the outer solar system, altering the delicate balance of planetary orbits once again? These are not just theoretical questions. The same processes that may have caused planets to be lost in the past are still at work today. With each new exoplanet discovery, we gain a deeper understanding of how planetary systems evolve, and we inch closer to solving the mysteries of our own. If lost planets once existed, their remnants may still be out there, hidden in the asteroid belt, lurking beyond Neptune, or even drifting among the stars as rogue worlds. As technology advances, our ability to detect and analyze distant objects improves, meaning that some of the mysteries surrounding these forgotten planets may soon be solved. Future space telescopes, such as those designed to scan for faint infrared signals, could finally reveal the elusive Planet 9. More advanced space probes could explore the outer solar system in greater detail, potentially uncovering clues about whether missing planets were ever there. Ultimately, the search for lost planets is a testament to humanity's relentless curiosity. We are driven to explore not just what exists, but what once was and what might still be out there, waiting to be discovered. The universe is a dynamic place, constantly evolving, and our solar system is no exception. Planets may come and go, but the search for them never stops. Perhaps one day, we will rewrite the history of our solar system entirely, piecing together the fragments of worlds that have vanished, uncovering new planets that have remained hidden, and finally answering the question, what happened to the forgotten planets of the solar system? The search for these forgotten planets is not just a scientific curiosity. It could also reshape our understanding of how planetary systems form and evolve. If planets have gone missing in our solar system, what does that say about the long-term stability of planetary orbits? Could entire worlds be ejected due to gravitational interactions, and if so, where do they go? These are questions that have profound implications, not just for the history of our solar system but for the fate of countless planetary systems across the cosmos. One of the most intriguing possibilities is that some of these lost planets have not disappeared entirely but have instead become rogue planets, worlds that have been ejected from their home systems and now drift through interstellar space. Scientists estimate that for every star in the galaxy, there may be several rogue planets wandering in the darkness between stars. If our solar system once had additional planets that were thrown out by gravitational interactions, it is possible that they are still out there somewhere, traveling alone through the Milky Way. If this is the case, then the history of our solar system is far more dramatic than we once thought. In its infancy, the Sun may have had more than the 8 planets we recognize today. Some of these worlds may have collided, while others were captured or expelled. Imagine a time when a lost world, perhaps the size of Mars or even Earth, was flung into the abyss of space, its surface freezing solid as it drifted away from the Sun's warmth. If such a planet still exists, it would be almost impossible to detect, as it would emit no light of its own and would be far too distant for current telescopes to observe. But what if we could find one? The discovery of a rogue planet that once belonged to our solar system would be one of the most profound discoveries in the history of astronomy. It would confirm that planetary ejection is not just a theoretical possibility but a reality. It would also raise new questions. Could such planets still harbor life? Some scientists speculate that even in the cold depths of interstellar space, rogue planets could retain subsurface oceans, warmed by the heat of their interiors. If so, then lost planets may not be dead worlds. They may still be active, evolving places, carrying the echoes of a solar system they once called home. Beyond rogue planets, there is another possibility that adds to the mystery. Could lost planets still be within our solar system, hiding in places we have yet to explore? The Oort cloud, the vast shell of icy objects that surrounds the solar system, remains largely uncharted. Some astronomers have speculated that if a lost planet were to exist, it might be hiding out there, beyond the reach of our telescopes. The Oort cloud is so far away that even our most powerful observatories struggle to see its contents, and if a planet-sized object lurked within it, it would be nearly invisible to us. One of the biggest questions surrounding the idea of lost planets is how they might have vanished in the first place. Some may have been absorbed into larger bodies, much like how Theia, the hypothesized Mars-sized planet that collided with Earth, may have merged with our planet to form the Moon. Others may have been destroyed entirely in massive impacts, leaving no trace behind except scattered debris. Still, others may have been thrown into highly elongated orbits, making them difficult to detect. There is also the possibility that planets can be hidden in a more unexpected way, not physically lost, but overlooked due to their unusual properties. Some theoretical models suggest that a planet with an extreme axial tilt or an unusual composition could exist in a part of the solar system we have not properly surveyed. For example, if a world had a thick, opaque atmosphere that absorbed most visible light, it might be nearly undetectable unless observed in infrared. If it were located in an orbit highly inclined to the rest of the planets, it could easily have escaped detection. Astronomers are now using increasingly sophisticated methods to search for these hidden worlds. The upcoming Vera C. Rubin Observatory, for example, will conduct deep, wide-field surveys of the sky, potentially revealing objects that have been missed in previous searches. The James Webb Space Telescope is also capable of detecting faint, distant planets by observing their heat signatures. If a lost planet still exists within the outer solar system, these instruments may be the key to finding it. But what if there are even more mysterious explanations? Some fringe theories suggest that the missing planets of our solar system may not have been lost in the conventional sense, but may exist in hidden dimensions or alternate realities. While such ideas venture into the realm of speculative physics, they are not entirely without basis. Some versions of string theory propose the existence of additional spatial dimensions, which, if they interact with our own, could potentially hide entire celestial bodies from our view. While there is no direct evidence for this, it remains an intriguing possibility that pushes the boundaries of what we understand about space and reality. The deeper we look into the cosmos, the more we realize how much we have yet to discover. The history of our solar system is far from settled, and the possibility that entire planets have been lost, hidden, or ejected only adds to the mystery. If we can solve the puzzle of these missing worlds, we may gain insight into the forces that shape planetary systems, the fate of rogue planets, and even the ultimate destiny of our own world. Perhaps one day, a future mission to the outer solar system will stumble upon the remnants of a lost world, a frozen, ancient planet that has remained undisturbed for billions of years, holding clues to a time when the solar system was young and chaotic. Or maybe, as our telescopes become more advanced, we will finally detect the subtle gravitational pull of a hidden planet, confirming that the solar system is not as we once thought. The search for the forgotten planets is not just about understanding our past, it is about unlocking the secrets of the universe itself. As long as there are mysteries left to uncover, the quest will continue, and with it, the hope that one day, we will finally bring the lost worlds of the solar system back into the light. If we were to find one of these lost planets, the implications would be profound. It would change our understanding of how planetary systems evolve and potentially redefine the boundaries of the solar system itself. But perhaps more importantly, it would serve as a reminder that even in our own cosmic backyard, there are still mysteries waiting to be uncovered. One of the most compelling aspects of this search is that it forces us to reconsider what we think we know about planetary formation and migration. Traditional models suggest that planets form from the protoplanetary disk around a young star and remain in relatively stable orbits. But if planets like Vulcan, Planet X, or Nemesis once existed but are no longer where they were predicted to be, what does that say about the forces shaping our solar system? Could planets be more transient than we assume? Are their orbits more chaotic than our models suggest? Some astronomers believe that our early solar system was a much more violent place than we typically imagine. It is possible that during its formative years, there were more than just the 8 planets we know today. Some of these worlds may have collided, merged, or been ejected due to gravitational disturbances. In this scenario, our solar system may have undergone a phase of planetary instability, where rogue worlds were flung into deep space or sent on trajectories that eventually led them to crash into other planets, or the Sun itself. This idea is supported by the evidence of massive impacts in our solar system's history. The Moon is believed to have formed from the collision of a Mars-sized body called Theia with the early Earth. The chaotic scars on Mercury's surface suggest it may have suffered a violent past. Even Mars shows evidence that it was once hit by a colossal impact that reshaped its northern hemisphere. If these kinds of events were relatively common in the early solar system, then it is not unreasonable to suggest that entire planets could have been lost in the process. But what if some of these planets were not destroyed but instead relocated to the farthest reaches of our solar system? The Oort cloud, a vast region of icy bodies that extends beyond the Kuiper belt, is still largely unexplored. Some astronomers speculate that if a lost planet exists, it might be hiding out there, too far away for current telescopes to detect. If a large planet were hiding in the Oort cloud, it would be nearly impossible to see with traditional optical telescopes. However, it might still exert gravitational effects on other objects. Some researchers have suggested that unusual cometary orbits could hint at the presence of such a planet. If a world of substantial mass lurks in the outermost regions of our solar system, its gravity would subtly influence the paths of comets and smaller celestial bodies, warping their trajectories in ways that could reveal its existence. One of the most compelling arguments for a hidden planet comes from the strange behavior of trans-Neptunian objects, TNOs, which are small icy bodies beyond Neptune's orbit. Some of these objects exhibit unusual orbital clustering, as if they are being shepherded by a larger gravitational force. This has led some scientists to propose the existence of Planet 9, a hypothetical world that could be many times the mass of Earth and orbiting far beyond Pluto. While this is not the same as the classical Planet X of the early 20th century, it represents a modern version of the same mystery. Is there an undiscovered planet lurking in the darkness? Even if we never find these lost planets, the search itself is invaluable. Each attempt to locate them has led to new discoveries about the nature of our solar system. The hunt for Vulcan, for instance, helped refine our understanding of general relativity. The search for Planet X led to the discovery of Pluto and later to the realization that Pluto was part of a much larger population of Kuiper Belt objects. The idea of Nemesis, while never proven, encouraged studies into the periodicity of mass extinctions and their possible astronomical causes. Could it be that the planets we seek were never real at all, but rather stepping stones toward deeper scientific truths? In some ways, the search for these lost worlds is as much about the questions they inspire as it is about finding definitive answers. The idea that planets could be missing or hidden forces us to challenge our assumptions and push the boundaries of exploration. One day, future space telescopes or robotic missions may finally reveal the truth about these long-lost celestial bodies. Perhaps a spacecraft venturing into the Oort cloud will detect an unexpected gravitational anomaly, leading to the discovery of a frozen, forgotten world. Maybe an advanced infrared survey will spot a rogue planet drifting between the stars, one that was ejected from our solar system millions of years ago. Or perhaps, as we refine our theories of planetary formation, we will uncover new insights that explain why these hypothetical planets never materialized in the first place. Whatever the outcome, one thing is certain: the history of our solar system is far from fully written. There are still countless mysteries to unravel, and the possibility of lost planets remains one of the most intriguing puzzles in astronomy. As long as there are questions to be asked and frontiers to explore, the search for the forgotten planets will continue. The search for these lost planets extends beyond just our solar system. It raises a much larger question: how many planetary systems have experienced similar fates? If planets can be ejected, hidden, or destroyed within our own cosmic neighborhood, then it is likely that this process has happened countless times across the galaxy. Our search for exoplanets has revealed an astonishing diversity of planetary systems, many of which challenge our understanding of how planets form and behave. The mysteries of our own solar system may, in fact, be common throughout the universe. Consider the discovery of hot Jupiters, gas giants that orbit their stars at extremely close distances. These massive worlds likely formed farther out and then migrated inward, disrupting their original planetary arrangements. In some cases, this inward migration may have caused smaller planets to be ejected entirely. Could our solar system have once had a similar dynamic, where a large planet's migration led to the disappearance of a smaller world? The idea is not far-fetched. If a 9th or even 10th planet once existed beyond Neptune, it may have been thrown into deep space or pushed into an eccentric orbit where it remains undetected. Another fascinating aspect of this mystery is the possibility that some of these missing planets may still exist within the gravitational influence of the Sun, but in orbits that make them extremely difficult to detect. Imagine a planet in a highly elliptical orbit that takes it hundreds or even thousands of astronomical units, AU, away from the Sun before slowly making its way back. Such a world would spend most of its time in deep space, nearly invisible to telescopes. It might only become detectable when it makes its closest approach, a journey that could take tens of thousands of years. This idea connects to the hypothesis of Planet 9, a proposed super-Earth or mini-Neptune-sized planet lurking in the outer solar system. While its existence is still debated, its potential discovery would be one of the most groundbreaking findings in modern astronomy. Planet 9, if real, would explain the peculiar clustering of some Kuiper Belt objects and could provide insight into how planetary systems evolve over billions of years. But it also raises an even bigger question: if one hidden planet exists, could there be more? Could the solar system contain additional planets that remain undetected simply because we have not yet looked in the right way? Another possibility is that some lost planets never formed properly to begin with. Theories about planetary formation suggest that there were likely several competing bodies in the early solar system, some of which were absorbed by larger planets, while others were destroyed in massive collisions. The solar system may have once been home to numerous planetary embryos, small worlds that never grew into full-fledged planets. These lost protoplanets may have left behind clues in the asteroid belt or in the chaotic orbits of distant trans-Neptunian objects. Beyond physical loss, there is also the possibility that planets could be hidden, in a different sense, obscured by unusual physical properties or environmental conditions. A world with a thick, dark atmosphere could be nearly invisible in visible light, requiring infrared detection to spot it. A planet covered in a reflective, icy shell could blend into the background of space, making it difficult to distinguish from smaller objects. If a planet were composed of exotic materials that absorbed most radiation, it might remain undetected despite being relatively close. Some even speculate that a lost planet could exist in an orbit perpendicular to the ecliptic plane, meaning it travels above and below the usual orbits of the other planets. Most planetary searches focus on objects aligned with the known planetary plane, so if a hidden world follows a vastly different path, it could easily escape detection. This possibility, while unlikely, cannot be entirely ruled out until more thorough surveys of the solar system's outer regions are conducted. There is also a growing interest in rogue planets, worlds that have been ejected from their home systems and now wander the galaxy alone. If our solar system has lost planets in the past, they may still exist as rogue planets, drifting in interstellar space. These planets, cut off from any star, are incredibly difficult to detect. However, recent studies have suggested that they may be more common than previously thought. Some estimates suggest that for every star in the Milky Way, there may be multiple rogue planets, many of which may have been ejected from systems just like ours. The idea of a rogue planet with a history tied to our solar system is particularly compelling. Imagine a planet that once orbited the Sun, carrying with it the same raw materials that make up Earth, Mars, and Venus. Over time, gravitational interactions with the gas giants sent it on an escape trajectory, and it was flung out into the void. What if, billions of years later, this planet were to pass close enough for us to detect it? Could it still retain some of its original features? Could it even harbor some form of life, preserved beneath an icy crust? Some researchers have even suggested that lost planets could be rediscovered in the future if they ever pass close to our solar system again. While the chances of such an event are slim, they are not zero. A rogue planet with a trajectory that brings it back into our system could provide an unprecedented opportunity to study a lost world that was once part of our cosmic neighborhood. The mystery of the forgotten planets is one of the most intriguing unsolved questions in astronomy. Whether these planets were real or theoretical, whether they were destroyed, ejected, or are simply hidden from view, their stories remind us that our solar system is still full of surprises. The search for lost worlds is, in many ways, a search for our own origins. Each new discovery brings us closer to understanding the forces that shape the planets we see today, and those we may never have known existed. As new telescopes and space missions push the boundaries of exploration, we may finally answer some of these age-old questions. Will we find evidence of a lost planet lurking in the Oort cloud? Will we detect a rogue world that was once part of our solar system? Or will we uncover new clues that suggest the history of our planetary neighborhood is even stranger than we imagined? Whatever the outcome, one thing is certain: the story of the solar system is still being written. The search for the forgotten planets continues, and with it, the hope that one day, we will finally uncover the full truth about the worlds that may have once called our sun home. The search for these lost planets is not just an exercise in astronomy, it is a journey into the unknown, a challenge to our fundamental understanding of the cosmos. It forces us to confront the possibility that our solar system, which we often think of as stable and well understood, may have a much more chaotic and mysterious past than we ever imagined. Could it be that our current planetary lineup is just a fraction of what once existed? Have we only uncovered part of the story, while the rest remains hidden in the depths of space? One of the most intriguing aspects of this search is the role that modern technology plays in our ability to detect celestial bodies. In the past, astronomers relied on visible light and crude telescopes to scan the skies for unknown planets. Today, we have a vast array of tools at our disposal: infrared telescopes, radio observatories, gravitational wave detectors, and even artificial intelligence algorithms that sift through astronomical data in search of anomalies. These new technologies may finally allow us to confirm or refute the existence of the forgotten planets. Take, for example, the ongoing search for Planet 9. Unlike previous hypothetical planets such as Vulcan and Nemesis, which were ultimately dismissed due to a lack of evidence, Planet 9 has some compelling indirect evidence supporting its existence. The peculiar clustering of trans-Neptunian objects suggests that a massive body, perhaps several times the size of Earth, is exerting gravitational influence in the outer solar system. The problem is that this world, if it exists, would be extremely distant, perhaps 10 to 20 times farther from the Sun than Neptune. At such distances, it would receive very little sunlight, making it nearly invisible to traditional telescopes. However, astronomers are now using new techniques to hunt for this elusive world. Some are scanning the sky in the infrared spectrum, looking for the faint heat signature of a distant, cold planet. Others are examining archival data from sky surveys, hoping to spot an object that has subtly shifted position over time. If Planet 9 is real, it may only be a matter of time before it is discovered. But if it is not, then we must ask, what else could be causing these strange gravitational effects? Could there be multiple smaller planets instead of one large one? Or is there some unknown force at work in the outer solar system that we have yet to understand? The concept of missing planets also ties into a broader cosmic mystery. How common is planetary instability? In the grand scheme of the universe, planetary systems may not be as stable as we assume. Many exoplanetary systems show signs of having undergone significant upheaval, with planets swapping places, being ejected, or even colliding with one another. If this is a common process, then it stands to reason that our solar system may have experienced something similar in its past. One potential clue comes from the structure of the asteroid belt between Mars and Jupiter. Some scientists believe that this region was once home to a full-fledged planet that was either torn apart by Jupiter's immense gravity or destroyed in a catastrophic collision. Others argue that the belt is simply a failed planet, material that never managed to coalesce into a single world due to the disruptive gravitational influence of Jupiter. Could there have been other, failed planets in the solar system's past, ones that never fully formed or were eventually lost to the void? There is also the possibility that some of these missing planets are still out there but have remained undetected due to their unusual properties. A planet covered in highly reflective ice could blend into the background of space. A world composed mostly of dark matter, if such a thing exists, might be completely invisible to traditional observation methods. Even a large, slow-moving object in the farthest reaches of the solar system could remain undetected simply because our current surveys have not yet covered the right area of the sky. The idea that planets can be lost, hidden, or ejected also has profound implications for our understanding of habitability. If a world was once part of our solar system but was later thrown into interstellar space, could it still support life? Some researchers speculate that rogue planets, worlds that have been ejected from their home systems, might retain warm, subsurface oceans beneath thick layers of ice. If this is the case, then the lost planets of our solar system might not just be barren rocks drifting through space. They could still be teeming with microbial life, surviving in the dark, hidden from view. This brings us to one of the most exciting possibilities. What if one of these lost planets were to return? While the chances are slim, it is not impossible that a rogue planet ejected from our solar system billions of years ago could, through a complex gravitational dance, be pulled back in by the Sun's influence. If such an event were to occur, it would be one of the most extraordinary discoveries in the history of astronomy. We would have the opportunity to study a world that was once part of our planetary family, a world that has spent eons wandering through interstellar space before finally coming home. Even if we never find concrete evidence of these missing planets, their stories still serve an important purpose. They remind us that science is a process of continual discovery, of questioning what we think we know and seeking out new answers. The forgotten planets may or may not exist, but the pursuit of these mysteries has led to some of the greatest astronomical advancements of our time. Ultimately, the search for these worlds is about more than just planets. It is about understanding the very nature of our cosmic origins. Every time we push the boundaries of what we know, we uncover new layers of complexity in the universe. The solar system we see today is just one snapshot in a long and dynamic history, a history that may have included many more planets than we currently recognize. And so, the search continues. With each new mission, each new telescope, and each new discovery, we inch closer to answering the age-old question, what else is out there? The universe is vast, and the mysteries of our own solar system are far from solved. Whether hidden in the darkness of the outer solar system, buried in the records of astronomical history, or drifting as lonely wanderers in interstellar space, the forgotten planets remain one of the most compelling enigmas in modern science. One day, perhaps sooner than we expect, we may finally uncover their fate. The idea of forgotten planets also raises a profound question: how complete is our understanding of the solar system? While we often think of our cosmic neighborhood as a well-charted region, history has repeatedly shown us that the universe holds surprises beyond our expectations. For centuries, astronomers have debated the existence of unseen worlds, speculated about their possible locations, and in some cases, even given them names before realizing they were chasing illusions. Yet, these mistaken quests have often led to genuine discoveries, proving that the search for missing planets is not wasted effort but a necessary step in refining our cosmic knowledge. One of the most well-known examples is the hunt for Vulcan, a planet that was once believed to orbit between Mercury and the Sun. The story of Vulcan is deeply tied to an anomaly in Mercury's orbit, a discrepancy that puzzled astronomers for decades. When 19th-century scientists observed that Mercury's perihelion, the closest point in its orbit to the Sun, was shifting in a way that Newtonian physics couldn't fully explain, they proposed that an unseen planet was tugging on Mercury's orbit. This hypothetical planet, named Vulcan, was thought to be hidden within the intense glare of the Sun, making it nearly impossible to observe. For years, astronomers claimed to have spotted Vulcan, but each reported sighting turned out to be an illusion, most likely caused by optical artifacts, passing asteroids, or even sunspots. It wasn't until Albert Einstein introduced his theory of general relativity in 1915 that the mystery was solved. His groundbreaking equations showed that Mercury's orbit was being influenced by the curvature of spacetime itself, an effect that Newtonian mechanics could not account for. With this revelation, the need for Vulcan vanished, and the planet was officially dismissed as a celestial mirage. Yet, the search for Vulcan was not without merit. It provided one of the first real tests of Einstein's general relativity, helping to confirm one of the most important theories in modern physics. It also demonstrated the limits of human perception, how easily our minds can create patterns where none exist, and how scientific progress often involves discarding old ideas in favor of new, more accurate ones. But while Vulcan was a mistake, the idea of hidden planets persisted. In the late 19th and early 20th centuries, astronomers turned their attention to another missing world, Planet X. This time, the mystery revolved around the orbits of Uranus and Neptune. When astronomers calculated the positions of these outer planets, they noticed slight deviations that couldn't be fully explained by known gravitational forces. Some believed that an undiscovered planet beyond Neptune was exerting its influence, just as Neptune itself had been predicted due to its effect on Uranus. The search for Planet X led directly to the discovery of Pluto in 1930. However, as time passed, it became clear that Pluto was far too small to account for the gravitational disturbances observed in the outer solar system. Instead of a massive world pulling on Uranus and Neptune, it turned out that earlier calculations had simply been off due to observational errors. Once those errors were corrected, the need for a large Planet X disappeared, at least in the form it was originally envisioned. Yet, the idea of Planet X has never truly gone away. Today, many astronomers believe that a different kind of unseen world, now called Planet 9, could be lurking in the distant reaches of our solar system. Unlike the old Planet X, whose existence was based on flawed data, the case for Planet 9 is built on the unusual orbits of distant Kuiper belt objects. These small, icy bodies seem to be clustering in ways that suggest a hidden gravitational force is shaping their movements. If Planet 9 exists, it would be a true outlier, a super-Earth or mini-Neptune lurking in the darkness, perhaps taking tens of thousands of years to complete a single orbit around the Sun. Some theories suggest that it could have formed in the inner solar system before being flung outward by Jupiter or Saturn's immense gravitational forces. Others propose that it might not be a native planet at all, but rather a captured rogue world that drifted into our system billions of years ago. If found, Planet 9 would redefine our understanding of the solar system, proving that even after centuries of exploration, our cosmic backyard is still full of surprises. But the search is not easy. The planet, if it exists, is so far away and so faint that even our most advanced telescopes struggle to detect it. It may take years, perhaps even decades, before we know for sure whether this lost world is real. Beyond Planet 9, another forgotten planetary hypothesis haunts the outskirts of our solar system: Nemesis, a hypothetical companion star to the Sun. The idea of Nemesis originated from a strange pattern in Earth's history. Some scientists noticed that mass extinctions seemed to occur at regular intervals, leading to the suggestion that a hidden celestial body could be disturbing the orbits of comets in the Oort cloud, periodically sending them hurtling toward Earth. According to this theory, Nemesis would be a dim red or brown dwarf, orbiting the Sun at an enormous distance. Every 26 million years or so, it would pass close enough to gravitationally disrupt the icy bodies at the edge of the solar system, triggering cometary bombardments that could explain extinction events like the one that wiped out the dinosaurs. Despite extensive searches, no such star has ever been found. Today, most astronomers consider Nemesis unlikely, arguing that the evidence for periodic extinctions is not strong enough to justify the existence of a hidden companion star. Instead, they suggest that comet impacts may be more random than previously thought. However, the search for Nemesis did contribute to our understanding of long-period comets and the structure of the Oort cloud, helping us refine our models of how the solar system interacts with its surroundings. As technology continues to improve, our ability to detect distant and hidden objects will only grow stronger. Future telescopes, such as the Vera C. Rubin Observatory, are expected to revolutionize our ability to track faint, slow-moving objects in the outer solar system. If there are any forgotten planets still waiting to be discovered, we may not have to wait much longer to find them. Ultimately, the search for these lost worlds is about more than just finding new planets. It is about pushing the boundaries of human knowledge. Every time we look deeper into space, we uncover new mysteries that challenge our understanding of how the solar system formed and evolved. The planets we know today may only be part of the story, with countless other worlds having once existed, only to be lost, destroyed, or ejected into the darkness of interstellar space. Even if we never find Vulcan, Nemesis, or the original Planet X, the legacy of these searches remains. They remind us that science is not a static collection of facts but a dynamic process of discovery, correction, and refinement. They also highlight the incredible power of human curiosity, the relentless drive to seek answers, even when the evidence is elusive. The forgotten planets of the solar system may remain hidden for now, but the universe is vast, and our search is far from over. Every new discovery, every advancement in technology, and every refined observation brings us closer to understanding the full history of our cosmic neighborhood. The question is no longer whether there are mysteries left to solve, it is how many more we have yet to uncover. The forgotten planets of the solar system are more than just abandoned theories. They represent the ever-evolving nature of science itself. As our understanding of the cosmos grows, the boundaries of what we consider possible shift. Ideas once dismissed as fantasy can become reality, while theories once considered solid can crumble under the weight of new evidence. This cycle of discovery and revision is what makes the search for lost worlds so compelling. Even though planets like Vulcan and Nemesis turned out to be miscalculations or misconceptions, they led to profound insights that reshaped our understanding of gravity, planetary motion, and even the very nature of space and time. However, the question remains, have we truly found all the planets in our own solar system? Or are there still hidden worlds waiting to be uncovered? One of the most compelling modern mysteries is the search for Planet 9. While the old concept of Planet X was based on errors in calculating Neptune and Uranus's orbits, Planet 9 is supported by real, observable anomalies. These anomalies appear in the strange clustering of Kuiper belt objects, small icy bodies beyond Neptune that seem to be influenced by an unseen massive object. The hypothesis suggests that Planet 9 could be a massive world, 5 to 10 times the mass of Earth, lurking in the distant reaches of the solar system. If it exists, it would orbit the Sun at a staggering distance, perhaps 10 to 20 times farther than Neptune. This extreme orbit means that Planet 9, if real, is incredibly difficult to detect. Even with our most advanced telescopes, an object that far away would be faint, requiring precise observations to confirm its existence. One of the most exciting aspects of the search for Planet 9 is that it aligns with what we see in other star systems. Most exoplanetary systems we've discovered contain super-Earths, planets larger than Earth but smaller than Neptune. Our solar system, however, seems to lack such a planet, which is unusual. If Planet 9 exists, it could be the missing link, explaining why our system is structured differently from those we observe around other stars. But if Planet 9 is real, why hasn't it been found yet? The answer lies in its extreme distance and slow movement. A planet that far out could take tens of thousands of years to complete a single orbit around the Sun, meaning it moves very slowly against the backdrop of stars. Spotting such a faint, slow-moving object requires advanced surveys and long observation times, which are only now becoming feasible with new telescopes. Scientists are hopeful that upcoming observatories, such as the Vera C. Rubin Observatory, will finally shed light on the mystery. The observatory's powerful survey capabilities could detect objects in the farthest reaches of the solar system, potentially revealing Planet 9 if it exists. But what if there are other, even stranger objects lurking in the outer solar system? Some astronomers speculate that our solar system may have once hosted additional planets that were ejected into interstellar space. These rogue planets could still exist, drifting through the galaxy as frozen, lifeless worlds. Could one of these ejected planets have once been a member of our solar system? There is also the possibility of ancient planetary remnants, fragments of lost worlds that were destroyed by collisions or gravitational disruptions. The early solar system was a chaotic place, with planets and protoplanets constantly colliding. Some researchers believe that a past collision between two large bodies could have created the asteroid belt or scattered objects into the Oort cloud, the distant reservoir of comets that encircles the solar system. In this sense, the forgotten planets of our solar system may not just be theoretical. Some may have physically existed before being destroyed or flung into the darkness of space. Their remnants could still be out there, waiting to be detected, or they could have shaped the very structure of the solar system we see today. The idea of forgotten planets extends beyond our solar system as well. Across the galaxy, countless star systems likely contain lost or hidden planets that have yet to be found. Some exoplanets may orbit in strange, highly tilted orbits, making them difficult to detect. Others may be hidden within the glare of their stars, much like how Vulcan was once imagined to be hidden near the Sun. One of the most mysterious exoplanet-related ideas is the concept of dark planets, hypothetical worlds that are difficult to detect because they emit very little light. Some theories suggest that massive planets could exist in interstellar space, drifting without a host star. These rogue planets could outnumber stars in the galaxy, forming an unseen population of wandering worlds. If rogue planets are common, they raise fascinating possibilities. Could some of these lost worlds have once harbored life? Could they still support subsurface oceans, kept warm by internal heat? If so, the search for habitable planets may extend beyond traditional star systems and into the dark depths of interstellar space. The mysteries of forgotten planets highlight an essential truth about astronomy: what we think we know is always subject to change. The history of planetary science is filled with theories that were once considered definitive but were later overturned. At the same time, ideas once thought impossible have turned out to be real. As technology improves, we will likely continue to discover more about our solar system's hidden past and present. The next few decades could bring groundbreaking revelations, perhaps confirming Planet 9, identifying long-lost planetary fragments, or even uncovering new categories of celestial bodies that challenge our current models. The forgotten planets remind us that the universe is vast and full of surprises. They show us that science is a journey, not a destination, and that every mystery we solve only leads to more questions. Whether hidden worlds still lurk in the darkness or if they were only ever illusions, their stories remain a crucial part of our quest to understand the cosmos. The search for these lost worlds is far from over, and as we continue exploring the outer reaches of space, who knows what other forgotten planets we may one day rediscover? The search for forgotten planets is more than just a curiosity. It is a reflection of humanity's relentless quest to understand the unknown. Every time astronomers propose the existence of a new planet, they challenge the limits of what we know about our solar system and the universe beyond. Whether it's Vulcan, Nemesis, Planet X, or the modern search for Planet 9, these quests have led to groundbreaking discoveries that have reshaped astronomy. But what if the forgotten planets aren't just a part of the past? What if there are still undiscovered worlds waiting to be found? The evidence for Planet 9 is compelling, but it raises deeper questions. If such a massive planet exists in the outer reaches of the solar system, how did it get there? Did it form in place, or was it a rogue planet captured from another star system? If it was captured, this would mean that our solar system has interacted with others in ways we never imagined, hinting at a dynamic and chaotic past where planets may have been exchanged between stars. The possibility of interstellar interactions leads us to another mystery. Could there be planets that once belonged to our solar system but were ejected into the galaxy? The idea of rogue planets, worlds that drift through space untethered to any star, has gained traction in recent years. Some scientists believe that there may be billions, or even trillions, of rogue planets in the Milky Way, many of them likely ejected from their home systems. If our solar system once had additional planets that were thrown out, they could still be drifting through interstellar space, frozen and dark, lost to time. These rogue worlds might still hold clues about their origins, including the chemical signatures of our solar system. If we ever manage to send probes beyond the heliosphere, where the sun's influence ends, could we someday stumble upon one of our own lost planets? The study of exoplanets has also revealed that planetary systems can be far more chaotic than we once thought. In some systems, planets exist in extreme orbits, nearly grazing their stars or being stretched into elongated paths that make them difficult to detect. Could our solar system have once harbored planets in unusual orbits that were later lost due to gravitational interactions? Some researchers have even speculated that our solar system might once have contained a second Earth-sized planet in the inner region. This hypothetical planet could have been ejected long ago in a violent collision or a gravitational dance with Jupiter or Saturn. If such a planet existed, it may have played a crucial role in shaping Earth's early history before being cast away into the void. Beyond our solar system, the idea of lost planets takes on an even grander scale. Many exoplanetary systems have structures that suggest planets have been rearranged or removed over time. Some stars have gaps in their planetary arrangements, places where a planet seems like it should be, but isn't. Could these missing planets have been destroyed, flung away, or consumed by their stars? Theories about planetary disappearance are not just speculation. Observations of young star systems show that planetary formation is a violent process. Collisions between protoplanets are common, and some planets are thought to be swallowed by their stars. Others may have been broken apart by gravitational interactions, leaving behind rings of debris that could eventually form new worlds. If this is true on a cosmic scale, it means that planetary systems are constantly evolving, losing and gaining members over millions or even billions of years. Could it be that our solar system, too, is still evolving, with planets yet to be discovered or even future planets forming from scattered material? The story of forgotten planets is, in many ways, the story of planetary science itself. Each generation of astronomers has proposed new worlds, only for some to be confirmed while others fade into obscurity. Yet, every search has brought us closer to understanding the architecture of our solar system and beyond. With the rise of new telescopes and observation techniques, we are entering an era where finding lost worlds may finally be possible. The upcoming Vera C. Rubin Observatory will scan the night sky in unprecedented detail, potentially revealing Planet 9 or even new celestial bodies we've never imagined. Space probes like the James Webb Space Telescope are allowing us to peer into distant star systems, witnessing planetary formations and destructions in real time. And what about the distant future? As technology advances, we may develop the ability to send probes to the outer reaches of our solar system, directly exploring the regions where lost planets may reside. If Planet 9 exists, a future mission could even visit it, confirming its nature and origin. Perhaps one day, humanity will find a rogue planet drifting through interstellar space and recognize it as a long-lost sibling of Earth. Perhaps we will uncover evidence of ancient planets that once orbited our Sun but were destroyed in the chaos of planetary migration. Or perhaps we will discover something even stranger, a planetary remnant that defies all expectations. The forgotten planets of the solar system remind us that the universe is still full of mysteries. They are a testament to our desire to explore, to question, and to seek answers beyond what is known. Whether these lost worlds exist in the far reaches of our solar system or beyond, their stories continue to shape our understanding of the cosmos. The search for these hidden worlds is far from over. In the coming years, we may finally confirm the existence of Planet 9, uncover the fate of ancient lost planets, and perhaps even discover new categories of celestial bodies that challenge everything we thought we knew. The universe is vast, and the possibilities are endless. The next forgotten planet may not stay forgotten for long. The search for forgotten planets does not just challenge our understanding of the solar system, it forces us to reconsider how planetary systems evolve over billions of years. What if the planets we know today are only a fraction of those that once existed? What if some planets were never truly lost but merely hidden, awaiting discovery in the distant reaches of space? Astronomers have long suspected that the solar system may have begun with more planets than we see today. Simulations of planetary formation suggest that the early solar system was far more chaotic than its present configuration. The gravitational influence of Jupiter and Saturn, the two gas giants, likely played a significant role in determining which planets survived and which were ejected into interstellar space. One prevailing theory, known as the Nice model, suggests that the solar system's early history was marked by violent planetary migrations. As Jupiter and Saturn shifted their orbits, they disrupted the paths of smaller planets, leading to some being flung out of the solar system entirely. If this theory is correct, then somewhere in the vast darkness between the stars, a planet that once belonged to our solar system could still be drifting silently, frozen in eternal night. But if planets can be lost, could they also be gained? Some scientists believe that the Sun may have captured rogue planets over its long history. These rogue planets, formed around other stars or ejected from their original systems, may have wandered into our solar system and settled into stable orbits. If such planets exist, they would be nearly impossible to detect with current technology, hiding in the cold darkness beyond Pluto. The idea of a hidden planet lurking in the outer solar system is not new. The search for such a world intensified in the late 19th and early 20th centuries when astronomers noticed peculiarities in the orbits of Uranus and Neptune. These irregularities led to speculation that an unseen planet, often referred to as Planet X, was exerting a gravitational influence on the two ice giants. This search eventually led to the discovery of Pluto in 1930, but Pluto was too small to explain the observed discrepancies. For decades, astronomers continued hunting for a larger planet beyond Pluto, but as observations improved, the orbital anomalies of Uranus and Neptune were found to be the result of errors in measurement rather than the presence of a hidden planet. However, the idea of Planet X refused to die. In 2016, new evidence suggested that a massive, undiscovered planet might still be lurking in the far reaches of the solar system. Researchers noticed that a group of distant Kuiper belt objects had orbits that were strangely aligned, something that could only be explained if a massive planet, about 10 times the mass of Earth, was pulling on them. This hypothetical planet, now referred to as Planet 9, remains one of the greatest mysteries in modern astronomy. If Planet 9 exists, it would be unlike anything else in our solar system. Its orbit is estimated to be incredibly elongated, taking it as far as 1,000 times the distance between Earth and the Sun. Such a planet would be incredibly difficult to detect with current telescopes, as it would receive very little sunlight and reflect almost no visible light. Yet the search continues. New telescopes, such as the Vera C. Rubin Observatory, are expected to revolutionize our ability to detect faint celestial objects. If Planet 9 is real, it may soon be revealed. But even if it is not, the search will undoubtedly uncover new mysteries, perhaps even the remnants of long-lost worlds. Another intriguing possibility is that the solar system may have once hosted an undiscovered super-Earth, a planet larger than Earth but smaller than Neptune. Some models suggest that a super-Earth could have existed between Mars and Jupiter before being ejected or destroyed. If this planet had survived, it might have dramatically altered the development of the inner solar system, potentially preventing the formation of the asteroid belt. The idea of a lost super-Earth raises even more profound questions. Could such a planet have once been habitable? Could it have harbored life before it was cast into the void? If so, could remnants of that life still exist somewhere, perhaps frozen beneath the ice of a distant rogue planet, waiting to be discovered? Beyond the search for hidden planets, there is also the mystery of planetary destruction. Some astronomers believe that the early solar system may have seen planetary collisions on an unimaginable scale. The leading theory for the Moon's formation suggests that a Mars-sized body, often called Theia, slammed into Earth billions of years ago, creating a debris field that eventually coalesced into the Moon. If such a cataclysm occurred once, could it have happened multiple times? Could other planets have been obliterated in similar impacts, leaving no trace behind? The asteroid belt between Mars and Jupiter offers tantalizing clues. Some researchers have speculated that the belt may be the remains of a destroyed planet. While the prevailing theory is that the asteroid belt consists of material that never formed into a planet, the idea that a world once existed there, only to be shattered by a cataclysmic event, remains a fascinating possibility. Another mystery lies in the strange orbits of certain objects in the outer solar system. Some of these objects have orbits that suggest they were once influenced by a much larger body, possibly a missing planet. If such a planet existed, where did it go? Was it ejected? Did it collide with another celestial body? Or is it still out there, hiding in the darkness beyond the Oort cloud? The Oort cloud itself is one of the least understood regions of the solar system. This vast, distant shell of icy bodies is thought to be the source of long-period comets, but it may also hide something even more mysterious. Some astronomers have speculated that the Oort cloud could contain large, undiscovered planets, perhaps even remnants of planets that once orbited closer to the Sun before being thrown outward by gravitational interactions. The idea of a hidden companion to the Sun has also persisted for decades. Some scientists have proposed the existence of a hypothetical star or brown dwarf, often called Nemesis, which could be lurking in the far reaches of the solar system. If such an object exists, it could explain periodic mass extinctions on Earth, as its gravitational influence could send comets hurtling toward the inner solar system at regular intervals. Although no direct evidence for Nemesis has been found, the idea remains an intriguing one. Could the Sun have once had a companion star that was lost over time? Binary star systems are common in the galaxy, and some researchers believe that the Sun may have formed with a twin that was later ejected. If so, where is it now? Could it still be out there, drifting unseen among the stars? The search for forgotten planets is not just about solving old mysteries, it is about expanding the boundaries of human knowledge. Every time we look deeper into space, we uncover new questions. Every time we think we understand the solar system, new evidence suggests we may be missing something crucial. Perhaps the greatest mystery of all is this: how many more forgotten planets remain undiscovered? How many worlds have been lost to time, erased by the chaos of planetary evolution? And most importantly, will we ever find them? The answers may lie in the future, waiting for the next great discovery. Until then, the search continues. The search for forgotten planets is not just a matter of curiosity. It has profound implications for our understanding of planetary formation, evolution, and even the potential for life elsewhere in the universe. If planets can be lost, hidden, or ejected, then our solar system's history is far more dynamic than we once imagined. Every anomaly, every unexplained gravitational tug, And every unexpected celestial body could be a clue pointing to an unseen world, waiting to be discovered. One of the most intriguing aspects of these lost planets is the possibility that they may still exist, not in some far-off star system, but within our own cosmic backyard. Astronomers have long speculated about the presence of massive objects lurking in the darkness beyond Neptune. These objects, whether rogue planets, super-Earths, or even failed stars, could help explain many of the strange behaviors observed in the outer solar system. Consider, for instance, the strange orbits of certain trans-Neptunian objects, TNOs. Some of these icy bodies follow elongated paths that suggest the gravitational influence of a much larger, unseen planet. This has led to renewed speculation about Planet 9, a hypothetical world that could be exerting a distant pull on these objects. If Planet 9 exists, it would be an entirely new type of planet, perhaps a massive ice giant, a super-Earth, or even a gas dwarf unlike anything currently found in our solar system. But if a massive, undiscovered planet still exists today, how did it go unnoticed for so long? The answer lies in the vastness of space and the limitations of our observational technology. Unlike inner planets that reflect large amounts of sunlight, an object as distant as Planet 9 would be incredibly faint, possibly emitting only a weak infrared glow. Until recently, our telescopes lacked the sensitivity to detect such an object, but advances in astronomical instruments may soon change that. The upcoming Vera C. Rubin Observatory, set to begin operations in the near future, is expected to revolutionize our ability to detect faint objects in the outer solar system. With its powerful sky surveying capabilities, it may provide definitive proof of Planet 9, or reveal something even more unexpected. Yet, beyond the hypothetical planets of today, there remains the question of planets that once existed but no longer do. The idea that entire worlds may have formed and then disappeared raises profound questions. How many planets did the solar system originally have? Could some of these planets have been habitable? And if so, what happened to them? One compelling theory suggests that the solar system may have started with more than 4 giant planets. Computer simulations indicate that an additional ice giant may have once orbited the Sun, only to be ejected by the gravitational chaos of Jupiter and Saturn's early migration. If this planet still exists, it would now be a rogue world, drifting through interstellar space, forever severed from its original home. Such an ejection would have been cataclysmic, disrupting the orbits of smaller bodies and potentially altering the entire architecture of the solar system. Some researchers believe this event could explain the strange tilt of Uranus, whose extreme axial inclination suggests a past collision or gravitational upheaval. Was this forgotten planet responsible for Uranus's unique orientation? Or was it the victim of another, even larger planetary encounter? Beyond the planets that may have been ejected, there is also the possibility of planets that were destroyed entirely. The asteroid belt between Mars and Jupiter remains one of the most puzzling features of the solar system. Traditionally, astronomers have believed that this belt is made up of material that never coalesced into a planet due to Jupiter's gravitational interference. But what if the asteroid belt is actually the remains of a planet that was torn apart? This idea, sometimes called the Phaeton hypothesis, suggests that a planet once existed in the region now occupied by the asteroid belt but was shattered by a cosmic event, perhaps a collision with another planetary body, a close encounter with Jupiter, or even internal geological instability. While no definitive evidence supports this theory, the idea remains intriguing, especially given the diversity of asteroid compositions. Could these asteroids be fragments of a world that once had a solid crust, a molten mantle, and perhaps even an atmosphere? If a planet in the asteroid belt was destroyed, what does that mean for the possibility of lost life? Could microbial or even complex life have developed on such a world, only to be obliterated in a catastrophic event? And if so, might traces of that life still exist, hidden within meteorites that occasionally fall to Earth? The concept of lost planets also forces us to reconsider the nature of planetary systems as a whole. In recent years, astronomers have discovered thousands of exoplanets, planets orbiting other stars, revealing a stunning diversity of worlds, many of which do not fit within the traditional planetary categories we use in our solar system. Among these discoveries are hot Jupiters, gas giants that orbit perilously close to their stars, as well as super-Earths, rocky planets larger than Earth but smaller than Neptune. If such worlds are common elsewhere, could our solar system have once contained similar planets that were later lost? One of the most fascinating possibilities is that our solar system may have once harbored an ocean world, a planet covered in vast, global seas. While some of Jupiter and Saturn's moons, such as Europa and Enceladus, are believed to harbor subsurface oceans, a true ocean planet, where water dominates the surface, has never been confirmed in our solar system. Could such a world have existed in the past? And if so, where did it go? Some researchers believe that an ancient ocean world could have formed in the early solar system, only to be stripped of its water due to intense solar radiation or gravitational disturbances. If such a world was ejected, it might still exist as a rogue planet, its once thriving oceans now frozen beneath an icy crust, drifting endlessly through the void. But perhaps the most tantalizing mystery is whether any of these lost planets might have harbored intelligent life. If entire worlds can be forgotten, what does that say about civilizations that may have once existed on them? Could there have been a time, billions of years ago, when a planet in our solar system developed advanced life, only to be wiped out by a cosmic catastrophe? If such a civilization existed, would we ever find evidence of it, or would time have erased all traces? The search for lost planets is, at its core, a search for the unknown. It challenges our assumptions, pushes the boundaries of what we think we know, and forces us to confront the possibility that our cosmic history is far more complex than we ever imagined. Every new discovery, whether an exoplanet, a rogue world, or an unexplained gravitational anomaly, brings us one step closer to unraveling these cosmic secrets. And so, the search continues. Perhaps one day, we will look into the depths of space and find the remnants of a world that once belonged to our solar system. Perhaps we will discover that the forgotten planets were never truly lost but merely waiting to be found. Until then, the universe holds its secrets close, whispering to those who dare to listen. The deeper we venture into the mysteries of the forgotten planets, the more we begin to realize that the history of our solar system is not as stable and unchanging as it once seemed. Instead, it is a dynamic, chaotic, and sometimes violent place where planets can be born, transformed, ejected, or even obliterated. The idea that we once had additional planets in our solar system, some of which may have been similar to Earth in their infancy, raises profound questions about the nature of planetary formation and the fate of lost worlds. One of the most persistent mysteries is the potential existence of a missing terrestrial planet between Mars and Jupiter. This hypothetical world, sometimes referred to as Phaeton, has been speculated to have once occupied the region now dominated by the asteroid belt. Some astronomers believe that instead of forming into a planet, the material in this region was prevented from coalescing due to Jupiter's immense gravitational influence. However, an alternative theory suggests that a full-fledged planet once existed there but was destroyed in a cosmic catastrophe. If Phaeton was indeed a real planet, what could have caused its destruction? There are several possibilities. One theory suggests that it collided with another planetary body, shattering it into the countless fragments we now recognize as asteroids. Another theory proposes that Jupiter's gravity pulled the planet apart over millions of years, gradually reducing it to a field of debris. A more exotic hypothesis even suggests that Phaeton could have suffered a planetary explosion due to extreme internal pressure or volcanic instability. The possibility of planetary destruction raises a chilling question. Could the same fate one day befall Earth? If a planet could be lost so completely that only fragments remain, it serves as a stark reminder of the impermanence of celestial bodies. What if civilizations once existed on such a planet, only for all traces of them to be erased by a cataclysmic event? Some proponents of the Phaeton hypothesis have even speculated that if the planet once had oceans and an atmosphere, it might have supported life, perhaps even intelligent life, before its destruction. But if we consider forgotten planets that may have been destroyed, we must also consider those that may still exist, hidden in the outer reaches of the solar system or beyond. One of the most enduring mysteries is the possibility of a hidden giant planet lurking in the darkness beyond Neptune, Planet 9. Unlike the purely hypothetical planets of the past, Planet 9 is based on observable evidence. The orbits of several trans-Neptunian objects, TNOs, in the Kuiper belt appear to be mysteriously aligned, as though they are being influenced by the gravity of an unseen object. The most likely explanation for this alignment is a massive planet, potentially 5 to 10 times the mass of Earth, orbiting far beyond Pluto. If Planet 9 exists, it would radically alter our understanding of the solar system. It would mean that the current model of planetary formation is incomplete, and that we have been missing an essential piece of our own celestial puzzle. But why has Planet 9 remained undetected for so long? The answer lies in its vast distance from the Sun. If Planet 9 is real, it likely follows a highly elongated orbit, taking it hundreds of times farther from the Sun than Earth. At such distances, it would reflect very little sunlight, making it almost impossible to detect with traditional telescopes. However, infrared surveys like those conducted by the upcoming Vera C. Rubin Observatory may eventually reveal its presence. Beyond Planet 9, there is also the question of even more distant, more mysterious planetary bodies. Some astronomers have proposed that there could be an entire Planet X population, undiscovered worlds in the outer solar system that exert subtle gravitational effects on their surroundings. If such planets exist, they could provide crucial insights into how planetary systems evolve over time. But even the idea of an undiscovered planet within our own solar system is not the most extreme possibility. Some researchers have gone even further, suggesting that the Sun could have once had a binary companion, Nemesis. The Nemesis hypothesis proposes that the Sun was originally part of a binary star system, with a faint, distant companion star. This hypothetical star, possibly a red or brown dwarf, would have had an elongated orbit that periodically brought it close enough to disturb the Oort cloud, a vast region of icy bodies at the edge of the solar system. These disturbances could have sent comets hurtling toward the inner solar system, potentially triggering mass extinctions on Earth. Although the idea of Nemesis gained popularity in the 1980s as a possible explanation for periodic extinctions, no direct evidence for such a companion star has ever been found. However, the possibility remains that if Nemesis existed, it may have been ejected from the solar system long ago, leaving behind only subtle clues of its past influence. If stars and planets can be lost, then the history of our solar system is not just a story of formation but of disappearance. This brings us to an even deeper mystery. What if some of the planets we have lost were never really part of our solar system to begin with? One of the most fascinating recent discoveries in astronomy is the existence of rogue planets, worlds that drift through space without a host star. Some of these planets may have formed in the darkness of interstellar space, while others may have been ejected from their home systems. If our solar system has lost planets before, could it have also gained them? The idea that Earth's planetary family might include an adopted world is not as far-fetched as it sounds. Some astronomers speculate that an object captured from interstellar space could be hiding in the outer reaches of the solar system, possibly mistaken for a distant Kuiper belt object. If such a world exists, it could be radically different from anything else in our planetary system, a relic of an alien star system that has traveled across the galaxy for billions of years. This possibility raises yet another intriguing question: could life exist on such a world? If a rogue planet was once part of another solar system, could it have carried microbial life from its original home? And if so, might it still harbor that life beneath an icy shell or within deep underground oceans? The search for forgotten planets is, ultimately, a search for our own origins. Every missing world, every hypothetical planet, and every unexplained gravitational anomaly adds another layer to the story of how our solar system came to be. The realization that planets can be lost, hidden, or ejected forces us to reconsider everything we thought we knew about the cosmos. What other secrets remain undiscovered in the vast expanse of space? Will we one day uncover definitive proof of Planet 9? Will we find remnants of a destroyed world in the asteroid belt? Or will we look beyond the solar system and discover that our celestial neighborhood was once far more crowded than we ever imagined? For now, the forgotten planets remain a tantalizing mystery, silent, unseen, and waiting to be found. The answers may be out there, just beyond the reach of our current technology. But as we continue to explore, to search, and to question, we move closer to solving the greatest planetary mysteries of our cosmic past. The more we unravel the forgotten planets of the solar system, the more we realize that our cosmic neighborhood is not a static arrangement of celestial bodies but a dynamic, ever-changing landscape where planets can emerge, vanish, or even be expelled into the void. Every discovery, every anomaly, and every unconfirmed hypothesis paints a picture of a solar system that is far more complex and mysterious than we once believed. The concept of lost planets is not just a relic of historical astronomy, it is an active field of study, one that could redefine our understanding of planetary formation, destruction, and migration. One of the most intriguing aspects of these missing worlds is the possibility that some may have played a significant role in shaping the evolution of the planets we see today. Take, for example, the idea that a massive lost planet may have once roamed the inner solar system, disrupting early planetary orbits and influencing the final arrangement of the worlds we now recognize. Some astronomers believe that if a large Earth-like or super-Earth-sized planet had once existed between Mars and Jupiter, its disappearance could explain some of the lingering mysteries in our planetary system. Could such a planet have been ejected into interstellar space? This question leads us into one of the most perplexing and exciting possibilities, that our solar system may have once had planets that were flung into the cosmic abyss, becoming rogue planets. These wandering worlds, untethered from any star, drift silently through the galaxy. Scientists now believe that rogue planets may outnumber stars, which means that many planetary systems, including our own, may have lost planets to the cold depths of space. The idea of planetary ejection is supported by computer simulations of planetary formation. These models suggest that as planets form, gravitational interactions can sometimes result in a world being flung out of its system. If our solar system was once home to an additional planet, or perhaps even multiple planets, that were thrown out by Jupiter's immense gravitational influence, they could now be floating through the Milky Way, utterly lost to us. But what if some planets were not ejected but instead consumed? This leads us to another forgotten planet hypothesis, one that suggests that the Sun itself may have devoured early planetary bodies. Some models of planetary formation propose that in the chaotic early days of the solar system, countless planetesimals and even fully formed planets spiraled inward toward the Sun. If so, they would have been incinerated and absorbed, leaving behind no trace except for slight chemical imbalances in the Sun's composition. This theory could help explain why the inner solar system lacks a super-Earth, despite the fact that these planets are incredibly common in other planetary systems. It's possible that one or more super-Earths once existed closer to the Sun but were gradually pulled inward and destroyed. If true, this means that our solar system may have been fundamentally different in its early years, with additional planets that were ultimately doomed by their proximity to our star. However, not all forgotten planets are lost due to destruction or ejection. Some may simply remain undiscovered. This brings us back to the persistent mystery of Planet 9, a world that, if it exists, may be lurking in the distant reaches of the solar system, beyond the orbit of Neptune. The search for Planet 9 has led astronomers to analyze the strange orbits of distant Kuiper belt objects, which seem to be influenced by an unseen gravitational force. The leading hypothesis suggests that a massive planet, possibly several times the size of Earth, is responsible for these anomalies. If we were to discover this world, it would not only confirm the existence of a hidden planet but also reshape our understanding of the outer solar system. The challenge, however, is detecting such a distant and faint object. Planet 9 could be orbiting hundreds of times farther from the Sun than Earth, making it nearly impossible to see with current telescopes. Its discovery may require next-generation observatories capable of detecting faint infrared emissions from cold, distant objects. But the possibility of Planet 9 raises an even deeper question. Could there be multiple undiscovered planets beyond Neptune? Some astronomers speculate that rather than a single large planet, the anomalies in Kuiper belt object orbits could be caused by a collection of smaller, icy planets. If this is true, then the outer solar system is far more complex than we ever imagined, hiding entire worlds in its distant, frozen reaches. Yet, even if we discover Planet 9 or other trans-Neptunian worlds, there remains another mystery: the potential existence of ancient planets that predate our solar system itself. One of the most astonishing possibilities in modern astronomy is the idea that some objects in our solar system may have originated beyond it. In recent years, astronomers have discovered interstellar objects, asteroids and comets that came from other star systems and briefly passed through our own. If such objects exist, then what if our solar system captured an entire planet at some point in its history? It is theoretically possible for a rogue planet, drifting through interstellar space, to be pulled in by the sun's gravity and become part of our solar system. If such a planet exists, it would likely be orbiting far beyond Neptune, where it would be difficult to detect. This could mean that we are currently overlooking an entire alien world, a planet that once belonged to another star but was drawn into our solar system long ago. This concept connects to the broader mystery of planetary migration, which has played a crucial role in shaping our solar system. Studies suggest that Jupiter and Saturn once moved dramatically from their original positions, disrupting the orbits of other planets and potentially altering the fate of forgotten worlds. If these gas giants shifted over time, what other worlds might have been caught in their gravitational dance? Could there be a planet that was pushed into the outer darkness, now wandering in near invisibility at the solar system's edge? The forgotten planets of the solar system are not just theoretical curiosities. They are fundamental to understanding our own origins. Every lost world, every hypothesized planet, and every unexplained gravitational disturbance tells a story of a solar system that has evolved in ways we are only beginning to comprehend. The questions surrounding these planets are profound. Did Earth once have planetary neighbors that no longer exist? Could an undiscovered planet still be lurking in the farthest reaches of our solar system? Have we lost planets to the cold abyss of interstellar space, never to be seen again? Could an alien world, born in another star system, be hiding in our own cosmic backyard? As technology advances and our ability to explore the cosmos improves, we may one day find answers to these mysteries. The discovery of even one forgotten planet would rewrite the history of our solar system, proving that planetary systems are not as static as they seem but are instead shaped by forces of creation, destruction, and migration over billions of years. For now, the forgotten planets remain hidden in the darkness, waiting to be found. Perhaps the next great astronomical breakthrough will reveal a lost world that was once part of our solar system's past, or even uncover a planet that defies everything we thought we knew about the cosmos. The search for these missing worlds is far from over, and as we continue to push the boundaries of discovery, we may find that the solar system is far stranger, more dynamic, and more mysterious than we ever imagined. The idea that our solar system may have once harbored planets that are now lost, destroyed, or hidden in the depths of space forces us to rethink what we know about planetary evolution. If a forgotten world once existed, its presence, or absence, could be the key to solving many of the lingering questions about our cosmic neighborhood. But as we continue to search for these lost planets, we must also consider the possibility that some of them never truly existed at all. Throughout history, astronomers have proposed numerous planetary bodies based on mathematical predictions, unexplained gravitational anomalies, or even observational errors. Some of these hypothetical planets were later proven to be illusions, while others were replaced with new theories that reshaped our understanding of celestial mechanics. The search for these missing worlds has shaped the course of astronomy itself, demonstrating the power of scientific inquiry and the limitations of human perception. One of the earliest examples of a forgotten planet is Vulcan, a hypothetical world once believed to exist between Mercury and the Sun. In the 19th century, astronomers noticed irregularities in Mercury's orbit. Its movement around the Sun did not match the predictions made using Newtonian physics. The French mathematician Urbain Le Verrier, who had previously predicted the existence of Neptune using similar methods, proposed that another planet must be affecting Mercury's orbit. He named this planet Vulcan and set off a frantic search for its existence. For decades, astronomers claimed to observe Vulcan, often mistaking sunspots or distant stars for the elusive planet. However, no definitive evidence was ever found. The mystery of Mercury's orbit was ultimately solved in 1915, when Albert Einstein's general theory of relativity explained that the warping of spacetime around the Sun was responsible for Mercury's peculiar motion. With this revelation, Vulcan was rendered obsolete, a planet that had never existed, yet had shaped decades of astronomical research. But not all hypothetical planets were dismissed so easily. The search for Planet X, a supposed world beyond Neptune, persisted for much longer. In the early 20th century, astronomers noticed irregularities in the orbits of Uranus and Neptune. Some believed that these anomalies indicated the presence of a massive, undiscovered planet lurking in the farthest reaches of the solar system. The search for Planet X led to the discovery of Pluto in 1930, but Pluto was far too small to account for the gravitational disturbances. Over the years, new observations and recalculations cast doubt on the need for Planet X. In the 1980s, astronomers using data from the Voyager spacecraft found that previous estimates of Neptune's mass had been slightly incorrect. When corrected, the irregularities in Uranus's orbit disappeared, removing the need for an additional planet to explain them. Yet, the idea of Planet X never truly faded. Today, many researchers still believe that a large, undiscovered planet, perhaps even the mysterious Planet 9, may be hiding in the outer solar system, waiting to be found. Another lost world that once captivated astronomers is Nemesis, a hypothetical companion star to our Sun. In the 1980s, some scientists proposed that mass extinctions on Earth, including the event that wiped out the dinosaurs, could have been caused by periodic disturbances in the Oort cloud, a vast region of icy bodies at the edge of the solar system. The theory suggested that a dim, distant star, nicknamed Nemesis, might orbit the Sun in a long, elliptical path, passing through the outer solar system every 26 million years and sending comets hurtling toward Earth. For decades, astronomers searched for Nemesis using infrared telescopes, but no evidence of such a star was ever found. Advances in sky surveys and star mapping projects have since ruled out the possibility of a large companion star hiding nearby. While the idea of Nemesis remains a fascinating hypothesis, it appears that the mass extinctions on Earth were more likely caused by geological and biological factors rather than an unseen stellar assassin. However, the absence of Nemesis does not mean that our solar system is completely isolated. Recent discoveries suggest that other star systems may have passed close to our own in the distant past, possibly disturbing the orbits of comets and asteroids. One such event may have occurred 70,000 years ago, when a small red dwarf known as Scholz's star came within a light-year of the Sun. Encounters like this may have influenced the trajectory of objects in the outer solar system, creating patterns that we are only beginning to understand. As our understanding of the cosmos grows, so too does our awareness of the gaps in our knowledge. The concept of forgotten planets reminds us that the solar system is not a fixed, unchanging place but a dynamic and evolving structure. Some of the planets we once believed in turned out to be illusions, while others may still be out there, hidden in the darkness. Whether we are searching for Planet 9, investigating the fate of lost super-Earths, or contemplating the possibility of rogue planets ejected into interstellar space, one thing remains clear: the mysteries of our solar system are far from solved. The next breakthrough in planetary science may come from improved telescopes, deep space probes, or even serendipitous discoveries made by amateur astronomers scanning the skies. Each new revelation brings us closer to understanding the true history of our cosmic neighborhood. And as we continue this search, we must remain open to the possibility that some of the most intriguing worlds, the forgotten planets, may yet be found, waiting to rewrite the history of the solar system once more. This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. Like the video and subscribe to the channel for more such amazing videos.